Welcome back to the Live Coding Alliance. My name is Kale. I'm the founder. It's a new channel. Don't forget to hit like and subscribe. We're working on something super cool. The LORC, low rank recurrent convolutional random number generator. As far as I know, I came up with it. We're going to be experimenting with different ways to generate random numbers. So right now I'm doing a split LoRA, which has a square matrix cut in half diagonally. You can do it one more time, but you can cut it one more time too. I don't know exactly how useful it is. So what we're trying to do is do heavy dimensional reduction each layer by removing one neuron each time. And this should work out good because the neurons are essentially like an abstract function. Each layer you got to think of as like it could be any function that you can think of. You know, you're just adding up a bunch of sums. So those sums could be like any kind of math function, like a polynomial or a linear algebra function or a binary function like an XOR. So you can do a lot more with a very small amount of neurons than you think. To do advanced things, you're going to need a whole bunch of neurons. But to be able to do what we are doing, which is we're taking 12 random number samples from either a pseudo-random number generator or a client-generated sub-second ID, which is what this is for, is a 64-bit UUID library. And we use a 64-bit or 128-bit public password. I'm sorry, wait, let me change that. No, it's we have in the 64-bit pattern, you could also have like 35 bits for an anonymous ID. So it doesn't do. I can generate I could take one random number and then turn that into two random numbers by splitting a square matrix in half diagonally. You could do 4. I think you could split it in half one more time. Because what you're doing with the backpropagation is like you don't have to have this matrix in a square, like a fully connected layer. It could be a triangle because inside of that triangle consists of a square inside of there. So we're trying to like maximize the utility of a very small number of perceptrons because we're training up our neural network on the CPU as we generate random numbers. And so we can't have too many perceptrons. So let's get going into this. Sorry, my bunny is like chewing on something and it makes me kind of cringe. What is the bunny chewing on? I think just the label. Hey, no. Baby bunny. Here's a baby bunny. Ooh. He's a cutie. She's a good girl, but she chews on stuff. The other bunny does not chew. She's not a chewer bun. This is a chewer bun, so she just won't stop. That was a little bit traumatic when they get picked up. You can grab them by their back and pick them up and then put your hand right underneath them. Generally, that is like kind of stresses them out, and sometimes, like if they move their back, it like kind of hurts their back. So you got to be careful. They don't like that. All right. So what did I do? I don't know if I'm going to use these prime numbers anymore. I was using the sample count was up here in the constant, and then I moved it down here. Huh. I don't know if that's exactly what I want to do. So what I need to do is I need to, each time I train a little bit of a neural network, I'm basically calculating e to the x repeatedly over and over again, nonstop. And I only got to go the algorithm that I found on the internet, the default was like 10 times through the algorithm. I don't know if that's accurate enough. I don't know whether or not it even matters, because it's all kind of like a little bit fuzzy in the neural network. So things being not precise aren't necessarily bad. Errors can build up over time, but a little bit of randomness in a neural network is generally considered a good thing. Even pseudo-randomness or quasi-random numberness. Because pseudo-random numberness, while it does have a pattern, it also means that there is a pattern. And what that pattern is could be pretty random, depending on how you're doing it. So the random number generator might be outputting pseudo-random numbers that are like a subset of each other. But then if it is combined with something else that is random, it is, the pattern is random, right? Just not the things inside the set that make up the pattern, right? So this isn't a bad thing. Like, we're using a low rank adaptation. So we go through and we go through our lawyer. Sorry, I keep yawning. I apologize. It's been happening ever since I like. Okay, so like the stream was going nonstop for years, and then there was all that censorship, and then Stream Effects took their OBS plugins off the open source. Like, dude started like charging for the open source GNU software that he was paid by a community to write. And like everybody relied on that plugin who live streamed, just about, because it had filters and some basic color grading stuff, like some blur filters and transforms. And then I don't know. He was trying to like add some augmented reality stuff that people really didn't want. I mean, maybe somebody wanted it, but like it was beyond the scope of the original project. But it was his baby, and apparently he wasn't allowed to redistribute some of the code in GNU license. I'm not sure whether or not that was true or not. Could have been true. Might not have been true. But he refused to. He started selling the GNU open source binaries on his Patreon. And, you know, everybody's getting hopping mad because he like broke the internet pretty much. Took down all the live streamers OBS plugin they relied on. And if you ask me, there's no way that that could be legal. He's charging money for GNU open source stuff, but it's so complicated to build that people can't build it. It's still open source. He says, apparently, but then, you know, you want to get the binary, then you have to pay for the binary. And I don't think that that makes it free and open source. I mean, yeah, it makes the source available, right? The source is available, but it's not free. It's only free, like, if you're savvy enough with C++ to build a OBS plugin. It is pretty irritating, I'm gonna have to say. What was I saying about that? So yeah, ever since I took the stream down, I've had problems. There's also this court thing. I'm suing my university. Might be making it illegal for the state to use preponderance of evidence to take our certain rights. Certain meaning they're not uncertain, as in the 9th Amendment. That could be cool. Might be getting a lot of media attention here pretty soon. Because that gives us a right to substantial evidence implied from the 14th Amendment Troxel v. Granville ruling, where the court said you have a right to substantial evidence burden when the state is going to take custody of your kids, which, because you have a First Amendment right to the care, custody, and control of your children, and it's recognized as the oldest, literally the first civil trials in the United States were family custody cases. And I'm getting derailed, but long story short, they used to say, you know, like the lady justice that has the scales and she's blind. So it originally meant that they said that the jury was to weigh the probabilities and balance the rights. Okay? So what this meant was that so the scale, it's not just supposed to be like whether or not the facts, you know, let's say you have preponderance of evidence, then you're weighing the scales, right? So the courts basically said that it was unconstitutionally vague. So then they went to preponderance of evidence. And then they said, oh, well, the evidence is just supposed to weigh. So what they did was they took off the rights. So it's supposed to be, you're supposed to balance the probabilities and the rights, right? So then it just went to, well, just balance the probabilities and you don't get your rights. It's like, what the fuck? That happened? And we allowed it. Yeah, the Supreme Court banned it in 2001, but they never updated any of the others. Nobody ever questioned whether or not it was legal. You know, I guess that our kids are the only thing that we actually care that much about. I mean, that would make sense to me, but it's bonkers crazy when you think about it, that they would take your rights and your property, take millions of dollars. Like they convicted Donald Trump of sexually assaulting E.G. Carroll because Trump said, grab her by the pussy in that Access Hollywood tape. There was no evidence. The jury said, Trump said, grab her by the pussy, so more than likely he grabbed E.G. Carroll by the pussy. Literally, that is exactly what happened, and wow, really? So that's going to be banned pretty soon. Donald Trump's going to be a big fan of me coming up here pretty soon. All right, I'm a sidetracked. I can't be doing that. So what do we got? LoRA dimensions, LoRA velocity start. Where are the LoRA velocities? I like live coding. I've had like a really hard time ever since that Stream Effects thing went down. And then OBS updates broke all my keyboard shortcuts and all that court stuff. I mean, the faster way to go about doing this would be to I just not care. I don't have the ability to care about this. This is going to be calculating something multiple times, but it's more dry that way. So these were constants, but oh yeah. So what happened was that I needed to change the LoRA, the low rank adaptation, to different dimension sizes so I can get a benchmark. So what was a constant now has to turn into, so we store, yeah, we have to turn into some class members. So here's the memory map. All right, we start out with 12 samples, random numbers between -1 and 1 that are non-zero. Doesn't matter. Well, the interesting thing about this algorithm is going to be benchmarking the poisoning of the neural network. Is how do you poison the neural network, dude? Because I'm taking client-generated samples. I don't think that they can poison the neural network. I don't think it's possible because of this technique that I'm using with the manual CPU neural network, where each time I calculate e to the x, I just XOR the result. Each time I do a division, I XOR the result. And then I save a running XOR. So a client gives me a random number. It could be a pseudo-random number. It could be poisoned. Like you could attempt to try to hack this, but it wouldn't really do you any good because I have a pseudo-random number generator. And I just mix your random number with the pseudo-random number and have the neural network correct that. So I really think it's completely impossible to hack this random number generator neural network. So we got the LoRA velocities. And so what we do is every single time we load up a neural network value, we do a running XOR of the neural network value. And we take the lower bits. So the exponents are not going to be as random. The exponents are going to be in a specific range in the neural network. Okay, so those aren't random numbers. What are going to be the random numbers are going to be an XOR of all the mantisses of the floating point numbers. That's going to give us a pretty pseudo-random number. It's going to be relatively random. Random enough. And if there is a pattern to it, it doesn't matter because the pattern is going to be random. Or if there's a pattern in the subset, then it doesn't matter because that pattern itself is random. So the pattern generates a sequence of numbers. But if the pattern is random, well, this can be useful for stochastic gradient descent, because what we've done is we've essentially like drawn a random line somewhere in multi-dimensional space, right? So we take our pseudo-random values, and then we're gonna chop up for each LoRA value. We're gonna take 2 bits. Those 2 bits are gonna be 25% left, 25% right, 50% don't move or don't accelerate. Sorry. It's 25% accelerate, 25% deaccelerate, 50% no acceleration change. Okay? So we take our LoRA velocity. We're going to be going from checkpoint A to checkpoint B in a constant loop. We may or may not store checkpoint max. In fact, we might even want to like start doing some mutations of checkpoint max after some number of millions of random numbers generated. So we're going to take our LoRA velocity and we're going to add that to our LoRA values. So we're going to have don't I need another one in here? Shoot. I'm missing the frames, huh? Wait, no, we just operate on one in the history, right? Wait, I'm a little bit confused. So we have our LoRA velocity and we add that to our LoRA values. I think in this particular memory map, I am just saving the LoRA values. So another option is, instead of saving the LoRA values, I could just store the acceleration vectors. There's a maximum velocity too. And I don't know what to do, like if it's, I think if it's, so we don't want the numbers to get too big or small. We want them to be, you know, in the sweet spot of the gradient. So we don't want to be stuck at a local optimum. All right. So I don't think that we want to be stuck with a pseudo-random number going too far one way. I think as long as it's random enough, it's okay. Because what we'll do is the numbers that get vanishingly small are just going to get vanishingly small and just disappear. The numbers that get very big, what we're going to do is we're going to go through and we're going to reduce those values using some sort of mathematical curve, right? maybe a sigmoid, something like that. You know, sigmoid's probably pretty good. You could do like 1 over e to the x. You know, this thing's calculating e to the x nonstop. What's another e to the x? All right, so we're going to take our 12 sample inputs. We're splitting our neural network in half. We might split it up 4 ways, but the thing is that I need, in particular, I need one 64-bit number that really I need like a 52-bit random number, because I'm storing the epoch in the, what do you call it? The 64-bit public password is not fully 64-bit. I should actually, because the epoch is too easy to predict. So if it's anonymous, there's going to be some extra bits. So my UUID system works with values that are between 0 and 1. Okay, so I could actually make this random number generator such that you give me a random number 0 to 1. That's going to work out just fine with the math. The difference in between -1 and 1 is only subtracting 6, so that you can add up 12 numbers between 0 and 1. Subtract 6, divide by 24. Sorry, 12. I'm sorry. Don't know what happened there. All right, so I'm taking my LoRA, splitting it in half diagonally. So let's say I'm presuming I'm going to need that the sweet spot is in a 9x9 LoRA, which means that I'm going to have 9 times 9 equals 81 neuron in my network. So typically we just do a fully connected layer. And if you're trying to find a complex pattern, that might work. What we do is we do like these dropout layers. So you'll go through and you'll take like random neurons and then just set them to 0 every once in a while. You'll probably use like the pseudo-random bits from the neurons. You'll XOR them together and then just take the mantissa of it. Mantissa means there are 64 bits in a number in JavaScript. Of those bits, 11 of them are an exponent. 1 of them is a sign bit. Okay? The exponents, they're going to be clustered in a certain area, and they're not going to be random. The other bits, though, are going to be the result of a division instruction. So whenever you multiply, you have a lot of patterns. So it's not as random. So it's only pseudo-random. But then you do a divide, right? And then all of a sudden the bits start getting really, really random at that point in time. The exponent bits are good enough for a pseudo-random number, but they aren't something that I would not plug them into a stochastic gradient descent algorithm unless I was stuck. If I was stuck, maybe I might reach for those exponent bits. Because, you know, if you're stuck with whatever more random, let's call it quasi-random. So pseudo-random means that it is kind of random, but not random. Quasi-random is the same. It means that it's the real deal. It's like a de facto. For example, a student code of conduct hearing is typically a pseudo-judicial proceeding. And this is part of my lawsuit because I got expelled from my engineering school for protesting the vaccine mandate, saying some insults to Democrats. And they said that I disrupted the administration of the vaccine program. So I said, no, you're using preponderance of evidence against me. They didn't actually present any evidence against me. They just declared me guilty because somebody accused me because I emailed in my insults on my vaccine petition, my religious vaccine mandate exemption waiver form. And so they charged me a $20 fine and kicked me out. Said I have to like write some sort of like essay or something about how like I'm a bad person and what I did was wrong, which violates my rights because they accused me of disrupting the law that the university gets their power from. Is what is it, like ORS 352.187? If you look in the chapter 352 for the word power, okay, it says that all the university procedures have the force of law, and procedures and rules have force of law. So they charged me a $20 fine, right? And this is their, I mean, everything they did was wrong, but that was the death nail for them. You know, they couldn't, well, not using any evidence to also, like, they shouldn't have just declared me guilty without any evidence. You can't, just because somebody says I disrupted it, that doesn't mean that I actually disrupted it, right? Like, they have to actually provide facts. So that's the 14th Amendment substantial due process. You got procedural due process, means that you got a right to the process that they say in the law. They say this is how the trial has to go, that's how the trial has to go. Else not, then you get off. So a quasi-judicial proceeding is functionally identical to a court trial. And you have due process rights. They observe the laws of evidence. What else? So when you say due process rights, that means the process that is due to you by law. All right? And so this means any law, if it says something, you know, that's what it says, and then I'm entitled to it, you know, however it says, and it's implied, determined by precedents to say. That's a lot. That's like a really complicated thing, right? You can tell I've been in a lot of courtrooms, right? So, a quasi-random number is one step above a pseudo-random number. Quasi-random numbers are very processor intensive because it requires checking a long sequence of numbers to make sure that you have not generated the same number in that sequence. And quasi-random number generators are not very random. They're just more spread out. Quasi-random numbers are spread out in a uniform distribution. Sorry. They form a normal distribution. They are not a uniform distribution. Right. So this is the key in between pseudo-random, quasi-random, and actually random. What is it? I mean, de facto random would be like the actual random. The one in real life would be because you could, if you took an actual random number generator, it might output pseudo-random numbers. right? Because because that is a random sequence, is a pseudo random number sequence, right? So I went off on a tangent. I think that I possibly might have like shared some information. So what does that mean for me? So I got the LoRA velocity. I get this LoRA history. Okay. And so what happened? So if I'm going to store just the acceleration, I could do that just by taking my pseudo-random number I generated from XORing all the neural network values. Because each time you train the neural network, those values are going to be different, right? So it's okay to use those for pseudo-random numbers because I'm only changing the acceleration at most once per training cycle, right? So every single time you go and you XOR those neural network values, the mantissa is going to be pretty reasonably, what do you call it? Random. Technically, it's pseudo-random, but from the perspective of the neural network, I mean, it's going to be random. But the key is, you know, you balance out your acceleration and velocity, making your numbers grow too fast. You just got to balance that out by either the numbers just vanishing and then eventually it'll have to go back because the fitness function won't be workable in that region, so it'll have to maybe revert back to a checkpoint. So we go from checkpoint A to checkpoint B. So let's say I'm on checkpoint A, I'm trying to find checkpoint B, right? And my numbers were pseudo-random and they went off the rails, lost the script. Well, what I would do is I would just revert back to the checkpoint A. So we're all right, so we take our 12 inputs, we take our output A and our output B. All right, now we're going to run our 3x3 determinant convolution filter on our inputs, output A and output B. This is going to give us a dimensional reduction from 36 down to 10. All right. So now we take these 10 random numbers and then run them through half of the LoRA neural network. And then we'll get an output A, and then we'll run it through the other output of the neural network, and then we'll do it as output B. So in order to calculate our overall fitness function, we're going to basically pretend that this neural network is, we're going to pretend that the neural network is, how do I do this? If I could just like scribble down in here, right? Do I have that? I don't. All my keyboard shortcuts broke. I have a document camera, but it's broken. It's just so upsetting. It's been broken for so long because my keyboard shortcuts are way too complicated. So I'm just gonna have to make an app because I want to share my keyboard shortcuts, but like they collide with things. They cause problems. So we need an app. We need one that specifically is meant to run. I have like 14 cameras in here, and I need it to be like set up a specific way. All right. So I'm doing a lot of talking, but I'm not doing a lot of programming. So perceptron count. This is dimensions and history count. Take. Oh yeah, we just store this when we create. Hold on, I don't even. Oh wait, is this going to be a problem? Yeah, this can't be here. So the problem is that I have to be able to train this thing in a different thread. Right. Just in case I'm getting too many random non-uniform distribution. It's okay if some of them are non-uniform distribution, as long as over time they form, sorry, not a normal distribution. As long as over time they form a normal distribution, then it's fine. So function. The export back. So bucket total. I'm gonna have to pass through here, huh? Wait. What's bucket total? Oh right, bucket total. X or something. Oh right. I'm not doing this anymore, huh? So originally what I was doing is I was taking the 12 random inputs and then XORing them. But I realized that this was an attack vector. So then I started doing some other methods to where I could XOR these and then use that to add pseudo-randomness that's cryptologically secure. Which makes sense, right? But like, do I even use this at all? I could just get rid of this. I don't really want to get rid of it. I guess I'm a code hoarder, huh? XOR bucket. Is that what I'm trying to do? I've moved over to a running XOR system. Some bucket sign system. The sign mantis because I'm -1. Oh, right. So this is this is needed for crypto statistics analysis. So this is I'm taking out the X opponent basically, and this is useful for determining whether or not the exponent is a Gaussian distribution or a bell curve, aka normal distribution. I should use the same word to describe things. I should just use the word bell curve because you don't know what a normal distribution is, but you know what a bell curve is, right? 12 is the magic number where when you add up random numbers, it starts to form a normal distribution statistically. Oh, there's the bunny doing something bad. No, no. Loves to chew on the wall. Like, bunny, you can't do that. Irritating. She's such a good girl. She's so cute. But then she chews on the wall. I don't like doing it by the bucket. Because why? Damn it. Hey, stop that. No. A bunch of little... He just gets the paint off the top. Just over time. Takes a little chunk out. Rabbits are cute, but you have to, like, protect your stuff. I don't think they're the right kind of pet for most people who rent, who can't afford. If you can afford to repair stuff, you probably would love rabbits. If you can't, they might stress you out. You could just stick them outside, you know? They're a good reason to go outside, to go pet them. They love pets. They're like nonstop love. Bunnies are so cute. I have Flemish giant rabbits, and they are really sweet. They're like big bunny puppies. They're like a really big puppy that's always afraid. They are definitely more like a puppy. So sample total. Random oh yes, the init numbers. So this is where I need the sample total. See, the problem here is that my documentation is over here for the class. And what? So the memory maps down here. I moved the functions to I think I'm going to have to move these back out. This just doesn't make any sense to stick these here. I stuck them there because in my mind I'm thinking, I'm like, oh yeah, well the dimension number is going to be different, right? So then I'll stick them in the class to encapsulate. Great. So these I wouldn't need. These I think I can safely hard code actually. I'll just do so input start. Totally don't want that. This is the same one. All right. So these ones, oh, the velocities, right? I'm gonna have to put them somewhere. So the idea is you want to access the data linearly to optimize the CPU RAM controller. Okay? We'll get the velocity. Let's think about this logistically. So I'm going to run my algorithm. Okay. So I'm going to access the LoRA history or the neural net values. Okay. But in order to do that, I would need to first run the convolution function. So let's say I want to run, I just want to get a random number. Okay. If I just want to get a random number, I'm going to be doing I might not need to run the neural network. So I run the neural network when the samples don't add to a normal distribution. Okay. And then what do I do? So the two ways of going about doing it are, one, I can go through each sample and then predict the standard deviation of that sample and then eject the one that has the highest standard deviation. I forgot what that other term that you look at is. So the standard deviation only tells you how far away from the mean it is. That doesn't tell you whether or not the value is not random. Let's go. All right. Now, LoRA velocity start. How do I restart the TypeScript server? Damn it. I forgot. It's been so long. VS Code, restart, TypeScript server. I haven't really had to restart it a whole lot recently. So Control-Shift-P. Control-Shift-P, and then TypeScript restart. Huh? Am I like, oh, right, function. I forgot to restart. I can't type, no. Oh yeah, turn the camera off. I can't do that, right? I don't want people going on to like overlay. Oh yeah. What happened? Okay. Yeah, I need my app. I'm gonna like crank out this app. This OBS live cam. Or sorry, OBS Multicam. So what I want is I want to be able to click my mouse, maybe hold down a keyboard button and click the mouse and then switch my cameras. And it'll be around in a circle, and I have my cameras set up around the room. And so this will allow me to put the cameras in a circle where they are, you know, I could change the order of them. And then we do the carousel camera. So we go, I have an HDMI matrix. The HDMI matrix is like, I have, right now I just have 4 cameras. Oh, I don't have the other one. So herein lies the problem. I'm opening up all kinds of windows. These keyboard shortcuts used to work, but now they don't work anymore. Both OBS deleted all my keyboard shortcuts, and now they got overridden with something else with the new Windows update. Correct. Yeah. I just want to get rid of Windows, dude. I don't like being able to not customize the operating system. I don't think that the operating system is where we need a corporation to make it its cash cow. I don't think that that's necessarily makes good for good products. We need more companies selling products like software in Linux, like Blackmagic. You can use DaVinci Resolve in Linux now. I think that's a game changer. All right. All right. I think this is the best live coding session I've had in a while. Because I had something to talk about. You know, if I don't have any progress, the thing about live coding is you have to make progress. You can't do live coding when you're just here just to do a live stream and you don't have any progress, because it's extremely demoralizing. It does not make you feel good. It makes you really question whether or not you want to do any of this. I don't know what the hell else I would do. I mean, I build things, you know. I do shit like this. I don't know. If you said quit this job and go do something else, I would probably go do the same thing. So we don't really, so we can keep track of the maximum number of dimensions because there's 53 manticipate, and you divide that by 2 and you get 26, right? So we can handle up to a 26 by 26 LoRA, which is, if you ask me, I don't think that's 676 neurons. That's just way more neurons than what we would need. We're going to really start getting diminishing results past like 12 neurons per network. Like, it's going to go up, it's going to shoot up, it's going to be like, and then it's going to like curve off towards the end. You can keep adding more and more neurons, but it just won't do you any good. So I'm pretty sure that we'll see this, because, you know, once you start to get up to, what did I just say? 26 times 26 is 667 neurons, and it's over here. I use a 4K screen, so I can do that. And then I have another screen. Boom, boom. Yeah, you like that? These are like a 15.6 inch 4K monitor, and then a 13.3 inch 1080p monitor. Highly recommended. And they're up next to my camera, so when I'm looking at them, like if I'm live coding, I can stand up. So I sit down and look at the bigger monitor, and then I stand up, and then can I show you what I'm talking about? So the oh yeah, right. This is the problem with the switch. I got a HDMI switch, so can't really. This is why we need the carousel cam. We need this OBS Multicam plugin because, you know, we got HDMI switch, right? And then we got 15-inch monitor, 13-inch monitor. So when I'm hacking on the live code, you know, I could put this over to a little bit of a pain with this. It's not too bad. Right. So, what was I saying? So this allows me to switch. It's a 6x2 HDMI matrix. So I got 6 HDMI inputs and then 2 outputs. Right. And then I got a capture card on my computer that has 4 inputs on it. So that is 8 inputs. And then, well, one of the other, sorry. So there's 6 on that. And then one of them I use a 3x1 HDMI switch to switch 3 different cameras. And then there's one of them is always on, and that's the C cam. So the center cam is always on, and then the left and the right. Problem is, you know, I'm like here, and then I'm here, right? And then so the 2 cameras are like opposite, right? So if I go like here, right, I'm facing the opposite direction. So this is one of the things that I'm going to be accomplishing here as soon as we get this random number generator. So I got the new UUID library, the sub-second ID, and so this thing was working with a 128-bit UUID, and now I have a completely new, radically different, way faster. You can still use a 128-bit UUID, but we only use, we can generate up to 2 random numbers between -1 and 1. I think probably just going to go to between 0 and 1 output. And then that extra sign bit just turns into randomness. So I think I'm just going to basically, I'm going to take so the idea is that you want to get those extra bits out of the 64-bit value. So, you know, them sending in random numbers between -1 and 1, really you would want to do between the negative min and max float values, or not quite the min. You would have to do a bounding from positive 127 exponent down to negative 127 exponent. And then you would, what am I doing? What am I saying? So we add up 12 random numbers. We XOR it with a running XOR from the manual neural network, CPU based. And then we can do up to 128-bit output. No, we can only do, so let's say its random number is between 1 and what do you call it? 0. That means that the exponent of the floating point number is negative. It's not going to be positive. So the mantissa has a hidden bit that gives you 53 bits that you then shift up and down with the whatchamabobber, the exponent, right? So f its if it's 1, then it would be exponent would have to be a -1. Or sorry, if it's 1, the mantissa is just going to be a regular integer. All right. So if you go less than 1, then everything's going to get shifted all the way over to the right of the mantissa. Is that the right way? The right of the mantissa. No, right? Right? Yeah, this way. Right. So there's 52 mantissa bits. So all of the integers up to 52 bits, these are going to be stored as a floating point number just as you would an integer. This is the key to understanding numbers in JavaScript and Python, is that it's just a 64-bit integer whenever it has no fractional component. Like if it's just an integer, and then you add like 1 decimal point onto there, boom, you've shifted everything up because you have the hidden bit, right? So that's the key that you got to understand about a floating point number, is that there's a hidden bit in the mantissa, and that bit only becomes active when there's a fractional part, because you're in base 2. Okay, so shifting up and down, your exponent bit just means you're shifting left and right. Right? So it starts out as an integer and everything's in the lower part of the number. Right? So that means there's a fractional part. Okay. And then so let's say all of the bits are 1. Right? So that's going to not be, let's say you set the exponent -1. And then you set all of the bits in the number to 1. Okay? That is not quite 1. That is 1 fraction of a little bit away from 1. So then you add 1 to that. Let me clarify because that was confusing. So I set my floating point exponent to a -1. Okay, my sign bit is positive. Now we set all the mantissa bits to 1. Okay, that is almost 1. That is 1 little fraction away from 1. What is my point? That means that when you generate a random number between -0 and 1, that number has 62 bits in it, because what you have done is your sign bit is always negative. So let us say that we included the value 1. We're generating a value from 0, including 0, to 1, including 1. All right? This is no longer a 62-bit number. This number is 62 plus, what is it? 1 divided by 2 to the 63. So just a little bit more. So you should probably, because of that, with the way the bits are working, probably never going to get probably not use 1. So it should be less than 1 and not less than or equal to 1. Here, let's document that, because that is definitely not, that is something I didn't realize until I actually said it out loud. It was like, oh shit. So what do we have to do? 11. 0, 0. Why is the spell checker so bad? Come on. NXN. Oh, so why am I doing this? So -1. What does -1 do? Hold on. Let me think about this. So why did I pick -1? Because the math works out the same. Where did I get that? I think I've seen it somewhere else, and then I just know how the math works. So I didn't really think about it. But now that I think about it, we're trying to generate a random number. So we want to throw out the sign bit, right? So let's say it's -1. Oh, right. Because now I can reuse the sign bit, right? So is that wise to do? So negative probabilities aren't really a thing. Probabilities are a probability density function, which has to do with the area under the curve. The probability of any particular random outcome in a probability density function is 0. It doesn't mean that the chance of it is 0. It means that the area under the probability density curve is 0, because in order for you to have a probability, it needs to be within a range. Okay? And so typically when we think of dice rolls, we think of them as just numbers and we add them up. Okay, we don't really think too much into it. But these integers each have a range. Range of 0 to 1, 1 to 2, so on. ... This is why we're able to actually come up with any sort of statistics at all. Because we've just assumed that the range is 1 for each of these values, but we didn't really think that there's actually a multi-dimensional analysis that we could do. We could use some vector calculus, and we can actually have a whole bunch of these things in a big table, and we can do some mathematical operations on all of them at the same time. So you have to do it with these the dimensions that we are working in. Where am I at right here? Random number. -1. Oh yeah. Pseudorandom number generators. 0, or sorry, -1 is less than x. Less than 1. It has to be that way. It cannot be -1 less than or equal to x. Here and after the dirty inputs. Okay. So the dirty inputs are the inputs that we do not know are good. Inputs 12 through 35 are recurrent input. We use 12 because it's the minimum that we can get away with using statistically. Because the thing about generating random numbers is it all comes down to statistics. So what you're going to want to do is basically I'm utilizing the sign bit that the client is giving me for different purposes. So you give me a number, I'm going to be generating two random numbers between 0 and 1, right? Yeah, so I need to take all right, so the sign bit is discarded because why? Because we don't want our neuron operating with any sort of negatives. We're just utilizing this for my server to siphon off some random bit. Do I even need that? I'm trying to do ninja backflip triple kicks with two swords in my hand through burning hoops of fire with a lion chasing me. Okay? So this might not be necessarily the best. So let's think about this logistically. So I'm generating random numbers. How do you go about generating random numbers? You can only sample the timestamp very infrequently. You can sample the network timestamp very frequently. The network timestamp, if you have access to that, is going to be your best source of pseudo-randomness, because the LSB of the timestamp are going to be very random because they're in picoseconds, right? So whenever you get that sample, it's pretty random. But the problem is, the more you sample it, the faster you sample it, the less random it is. What was I saying? Okay, so I need to touch on the topic of the bit. So this is 363-bit random number. Oh yeah, turn the camera back on. usually have a keyboard shortcut, but that one disappeared. Or maybe I wasn't using it right because I haven't used it in so long. 12 dirty sample input and divide by 24. You add sign probability. That works, right? What is the spec? Oh, 754 I should know. So this is going to result in the random number be bounded by the first off, let's say I took in random numbers from negative infinity or negative maximum to positive maximum. Okay. So now let's add up 12 of those. Okay. You can see that there's a problem here. What am I going to use, 128-bit number to like store my intermediate calculations? You know, yeah, this ain't going to work out. Okay. So what do we do then? Well, yeah, this is why we generate random numbers as probability. All right, this probably doesn't go here. Probably want to put this at the end. There's a lot of ways to get a random bit. So let's say somebody else was just we just steal that other random value. So I guess the question is then at this point in time is like, what effect would the... So first off, let's think about this. So I'm going to take this means that my output is going to have to also be bounded from -1 to 1. Yeah, it's going to be way better if we just bound it from... We can bound the input from -1 to 1, no problem, because we're just adding up 12 numbers and then dividing by 12. And then we don't need to shift. So if we're doing our probability density calculation on the random values 0 to 1, we would just add the numbers up, divide by 12, and then, add the numbers up, add 6, and then divide by 12. Okay. Right, because let's say they were all the numbers were 1. Right. We're trying to output a random number from So there's two ways to skin the cat. Okay, so we could output with our neural network with very large number. And we all of our probabilities can be, you know, let's say like within 1/12 of the maximum value. We could just the neural network could output. We could just treat those values as if they're 0 to 100%. Neural network will actually learn that mathematics because with the neural network, each layer in a neural network is essentially a different mathematical function, like an abstract function. It can be absolutely anything. This is the key to understanding a neural network. The more neural networks you have in a layer, the more abstract functions you can perform. Okay? If you understand this about neural networks, everything else makes a lot more sense. When you look at those networks, you're like, okay, so why are they making it bigger and then they're making it smaller? Or they're sliding this thing along like, I don't know. I remember when I first learned that stuff, it was like, what the hell is going on? Why the hell are you doing this? What are all these dimensions? Did you come from a different dimension? Are you an alien? You know, this is like kind of weird, you know, but it's not really actually that weird. It's just I think the easiest way to explain it is what's going on under the hood in the neural network is actually really easy, but the way that everybody explains it is like it's not they're like trying to show off. It's that like they all have these like research papers, and you know they have to have a certain amount of mathematical rigor, and so they make a relatively simple thing into like pages of things that explained with a bunch of like squigglies, and like you might need a math degree to understand it, but relatively simple to understand if somebody explains it to you. Now, trying to actually do the math and, you know, like somebody gives you a word problem and then you're, you know, solve for, you know, ABC, that's a whole nother story. To actually understand what's going on under the hood is, you know, if you had a good teacher who uses makes some Python animations, I think you can understand what's going on because it's not really that strange. It's just like the math is difficult for you to do, not difficult for you to understand because it's just a slope. It's just difficult to understand how you actually calculate those slopes and what number you need to tweak in order to get the results that you want. Oh, where'd it go? So what's the next step? Next step. So we got that documented, right? So I can just click this and then go back to the code. Is this okay? All right. So I want to do something important. Got a bunch of compiling errors here. Wait, that's not it. Okay, so first off, where is the history index? The history is a ring buffer. So we store wait, so don't I need a target, right? Check point target. All right, so we have a set of neural network values. We take our LoRA, and then we're going to do our matrix multiplication to take our n and our n transpose matrix and turn that into a square matrix. I swear, if you read the LoRA research paper, it makes it sound so freaking difficult. I mean, the level of cryptography in the way that they explain that is just like unnecessary, dude. I think that research paper is a prime example of how you should not write a research paper. So we got a checkpoint target, and then we have a history index, right? LoRA history count is this in? Error threshold? What the hell is this shit? Is that a oh, it's a constructor. What is that? 89. Yeah, I stopped using the auto formatter a long time ago, by the way. I don't really like it. They take all the fun out of it. Especially the C++ standards committee, man. Those guys. I mean, I think C++ programmers are some of the most unhappy. C++ and Rust programmers are some of the most unhappy programmers out there, period. I swear to God. Oh, yeah. And then also web developers, the boot camp grads. The guys who are not doing well. If they're doing well, they're probably enjoying life. If they're not able to cut it in the grinder, they're not doing good. The boot camp grads, probably a lot of people committed suicide from those boot camps because it didn't pan out and they invested all this money into it and time. They turn out homeless and shit. Happened to a friend of mine. So what is it? History index? And that's the construction. The last index used in the samples. Reset count. I'm never going to call reset. That one's gone. It's too expensive. Wait, hold on. Yeah. Samples, spare bits. This would be where I stick those spare bits. Okay, so how do I want to do this? Okay, so there's one XOR for I want to say that this is the public XOR or this is the private XOR. I don't think it necessarily matters because there's no way that somebody could recreate the neural network on the fly to hack the random number generator, because maybe if you had a lot of samples, but the thing is there's just so much randomness. You would be having to predict a lot of different things. So first off, we're taking the determinant. What does the determinant mean? Remember, that one's, if you remember from vector calculus, or maybe you took linear algebra 2, you know what a determinant is? AD minus BC. Or it's much more complicated for a 3x3, not that complicated. Where is it? The determinant. Reduced dimension count. What is this? Convolution start. Sample count. might as well just write this C style. I started moving these functions in here because I'm like, all right, well, you know, encapsulation. It's just I don't really like. I know enough about programming to where it's like I just don't need to do that. I mean, it's not too much of a bother to wrap it. You know, that's what your dad should have done. Your dad should have done it. You should do it too. Ah. All right. What do we do? These ones make sense to do in here because I have this divide function is where I XOR. So I just basically this is the only real difference in between me and the other math functions. You know, I just take the standard one, I just replace the divide with my divide, which is slower. But the thing is like in order to calculate out a random number, I go through this loop some number of times. So how many divisions am I doing? This is what we're really looking at for the performance. Seeing how many divisions am I doing? Like right now I'm set at 10. You know? So what do I do next? What I need to do is I need to convert this into do X number of samples. I mean, honestly, I think I could do 2 samples. Would be random enough. I mean, you might want to do 12. I mean, if I just change this to 12, what would I do? Don't I want to change the number of e to the x calculations? Let's change this so that I could get some statistics on what is the best value. Training loop count. Checkpoint target. Gonna be 0 or 1. So what does that mean? That means I'm looking for a local optima. Oh, so we need to keep track of the last local optima, right? Optima. Oops. Okay, so each time we go through, we're going to go through, let's just do this right now. Because all of them are going to need to do this, except for whenever we find the local optimum. Right? Yeah. This I shouldn't have here. I'm just going to delete it. What do I do? I need like a function. It's like push random bit or something. What do I do? Like what? Push random bit. All right. So next we need to do. I don't want to have to XOR this thing again, but just to be safe, I guess we're gonna have to do this. That's spare bit. Well, that's convenient. I usually find that stuff to be pretty annoying. Sometimes it's okay. I think as a whole, it's just annoying if you're good at programming. It's not annoying if like I'm trying to learn a new API. If I can have just like random code snippets pop up where I'm like, oh hey, sometimes I'm like, yeah, I didn't know you could do that. Possibly undefined. What the hell? Wait, hold on. What the fuck is this? This is a bunch of garbage and I didn't even fucking look at it. What the hell is this? Okay, like I'm a bit twiddling master, bro, and like this I didn't even I don't want to use this AI shit, dude, because like I looked at that, I'm like, oh hey, snippet of code. Oh, just go, chunk. I could have written this code in like 10 seconds, dude. Possibly undefined, dude. I don't like that shit. Wait. What does a big int API do? All right. What do we got here? Where's the API? Not a whole lot going on there, huh? Just constructor instance. Good. What is all operator overloaded stuff? There's not really much in the API. All right. I think they just do operator overloading for that. Nothing, no big deal, whatever. What the hell am I even looking at? Possibly undefined. What the hell? Zero and what am I supposed to do with this? What the hell? This thing's going nuts. Huh. There we go. I was going crazy there. I'm like, oh shit, I don't know how to do basic things. I guess I gotta quit, huh? All right. Do I need this every time I divide? Uh, I just took one algorithm that I got off the internet. I need to look up some other algorithms. Something like on GitHub. I don't know what it is. What is it doing? Can like I forgot which one's the McLaurin series. Okay. Um, trying to think of what the hell I would be a good source for that. Wikipedia. And so long since I've looked at this, I mean, I understand concepts, but forget what. That's all I'm doing. Wouldn't I want it to be like within a certain value? or a certain range of. So like, wouldn't I want to have like first off, we would need a. Excuse me. What do I need to do? Like take a. So what I need to do is I have to convert this into a state machine. So like I need to be able to run this a certain number of times. And I need to be able to program that. So I guess I'm gonna just a lot of values in here. History, call count, error count, last index. The errors, I'm just basically rebounding them because whatever the neural network output is going to be, it's going to be pretty freaking random. If the output is not what I want, I can just chop off the sign bits. Then it, you know, whatever. As long as it's a random number between 0 and 1, it's all good, dude. I really only need 53 bits because I use 64-bit UUID library. I think I started explaining the 64-bit UUID library, but so I only need 64 bits to identify something temporally. 128 bits is like universally unique, but not needed if you. Universally unique means like I can, it's like imagine I had one hash table and I stuck everything in one hash table. That's what universally unique means. You could call it globally unique. Might be more globally unique, but might be a little bit more accurate actually. But what do I need to do? I need to store what? X and N. Oops. Wrong button. N. So what? Now I do. I need the number of times I'm going to go through each iteration. I want to say end iter. I should stop calling it UUID in here. In this context, I'm actually just like legitimately like a random number generator. Per. No, I don't. It's not a loop. Iteration. Number of iterations through ELEX calculation. Call it a trigger. N iter. N iter is going to be number, no. Wait, no. N. No. That makes sense. N per, so N iter is the number of times through iterations through e to the x. Loops per trigger. Cycle. Cycles through e to the x loop per trigger. Okay, sure. Trigger, I mean, you understand a trigger means, you know, when I trigger a random number generator, what does that mean? Does that mean I outputted a random number? No, it just means I triggered it. I ran the algorithm. I might have to run the algorithm 10 times in order to get a valid output, right? Right, so iter cycles through. Let's just do n per trigger. Do I need e to the x? Because I'm also going to do a square root. N cycle for calculation. X stored value for run. Should I call it a running calculation? Should I just call it running calculation? X stored value. N per trigger, N per calculation, X. And that's after N, not N per trigger. What do we do? Per trigger. Trigger threshold. We could put it at the end. care about this. I mean, I like it being n per, because we have n per trigger. I mean, clearly it's related to n here. I'll keep it this way because it's nice and clean. N per trigger. Number per calculation. Nope. So what do? I generate? No, I don't need the generate. I only need the reject, because what is that for? So I need to debug. Therefore, I need a list of numbers in my list of prior numbers. I check to see whether or not the algorithm is prone to generating the same output from the same input. And then if it never generates the same input from the output, because I don't think that it would. Just, you look at the way the neural network math is shaped up, you're like, first off, I'm running a convolution algorithm on my inputs and my outputs. And then I've gone into determinate land, right? So it's not like I'm not going to be what am I trying to say? So my input and my outputs are all going to be between what, 0 and 1? Because it has to be a probability density. And then if you want to add on the random bits for the sign bits beyond that, that's like a good random number generator doesn't output signed values. It's going to output a unsigned value. There's a benefit to me taking random samples from the client, because what does it allow me to do? It allows me to detect bad actors. So, oh yeah, input. Right, so dirty input. I need to do a dirty input and then an input. All right. Let's do dirty inputs. I might remove these later. We got dirty inputs and we got clean inputs. Okay. So our dirty inputs, what we're doing is we're detecting malicious actors, bad input. Okay. And then our clean input are going to be XORed with our running XOR. So let's take a sample and then we're going to go, probably turn off the expensive camera. Got the Sony FX30 going with the Viltrox 9mm f2.8 autofocus lens. Picked up for 150 used. I mean, seriously, damn. That camera lens is pretty good for what are they charging? $200 now. Worth every penny, dude. Because you use that clear image zoom, and then that turns into 4K. What is it? 9 times 2.25? 20.25 lens, 4K, and then you crop in on that. Boom, that's double that. So that's like, a 40.5mm lens right there, dude. I mean, that's pretty good for a dude. I mean, that's for a desk. That's pretty good, dude. There's no bokeh, but who cares? I got a AI green screen, so. And then you don't need that autofocus AI chip. If you got that 9mm, because there's no bokeh. The autofocus could be contrast detect, and it wouldn't make a difference. Well, it wouldn't make much of a difference. No, actually, if it was bad contrast detect, it might be bad. No, because it doesn't hunt. Because there's no bokeh when it's ultra wide angle. All right, I need to focus though. So what are we doing? Where's the XOR come in? So I got my sample, right? So I take my random number. Where do I call it? Because this seems like I should be outputting an error. Well, isn't the error going to be a 0, right? Because we're never going to have 0. We'll just say that statistically, getting 0 would just not happen. There's this deal. Okay. I wish that older people would get with the program with texting. They oftentimes they want to call you on the phone from Craigslist. I mean, I always have good interactions with those people. I don't have anything bad to say about that group of people, but it's like I don't want to talk on the phone with a bunch of random people. Like I'm at work, I can send you a text, dude. Like I'm just trying to sell you something for like $20-$30 that I probably paid more for. People need to respect your time. Get with the program, dude. Send a text message. Some people are really against it, especially on Craigslist. Oh yeah, I was looking into that algorithm, right? What's the best E to the X algorithm? Taylor series. I'm just really confused on which one you calculate E to the X with. I just grabbed the Taylor series maybe off of something like Stack Overflow. I don't really remember. This really just what Taylor series is that? I just wish that they had Wikipedia just doesn't have good grab and go stuff for people who know what they're doing. Sometimes it's okay, but it's like, okay, well, where's the E to the X function? It's not like I can just like search for E, you know? That doesn't work. Oh, here we go. Right. Which is X to the N. 2, 3. So X to the N. How do we calculate this? Just like keep the X and then the N separate, right? Oh, this should be really fast to calculate, right? Let's just document this. Huh? I hate that. Stupid keyboard shortcut. I don't even remember which one that is. Is that? I hate having keyboard shortcuts in my IDE. I want my keyboard shortcuts for my cameras, dude. I just don't need keyboard shortcuts. I just never really grew into, I mean, I like some keyboard shortcuts, but like, dude, this stuff requires a lot of thought. Like, being able to type just a little bit faster isn't really going to help me out. That's the thing. It's like, people who are obsessed with Vim, I don't think they're actually doing enough hard stuff, like Prime Agent. Like, dude's really smart, you know, he's got the master's degree. I know he knows, did manual neural network in college. I know he knows advanced mathematics. And then, you know, he's like a Vim freak. You know, he's all about it, but it's like, okay, where's your cool app, bro? Right? Like, oh, well, we got this terminal coffee app, bro. Like, okay. I mean, yeah, that's cool. Clearly, you just don't give a fuck about money like that. And that I respect the guy for sure. I'm not talking shit about that. I mean, but it's like, you know, where's your scientific achievements, right? Terminal coffee app isn't really too much of a scientific achievement, right? Like typing a little bit faster. Like, dude, a lot of these dudes making these scientific advancements, they type really slow, dude. I'm not sold that there's any one particular thing that's going to be a game changer for you. I think the game changer is going to be the combination of things. And it also has to take into account your present circumstances and where you're going, and the network around you, and the resources you have available, and your drive to continue going when shit hits the fan and nobody's there to pat your back or hold your hand. What am I doing? Oh yeah, so the e to the x thing. Don't I need one more variable? Wait, x stored value for. Wait, it's e to the x, so x is What is X? Right. So this is a stored value. The N something keeps collapsing on my. Oh, it's that keyboard shortcut for switching the desktop. I switch the desktop and it collapses all my code. I hate that. Need the app. I gotta keep driving, dude. Honestly, I've had a lot of trouble with live coding recently. It's been a burden. Like with the court thing, court disrupted everything, so whatever flow I had was gone. And so I really been struggling between trying to recover from stream effects going down through all the OBS updates causing all of these problems, like resetting the keyboard shortcuts, plugins no longer working. Yeah, it's just been like you know, a part of me that was like for years, like that's what I did all the time, and then it was like gone. I've been pretty upset about the censorship, for sure. So why am I storing the dirty input? Yeah. I'm just going to call them clean inputs or the pseudo-random. So the dirty inputs are potentially poisoned by hackers. Okay, but we're going to do an analysis to check to see whether or not they're trying to poison my well. And then we got the clean input, which are going to be our pseudo-random numbers. So what do we have to do then? Sample count. Clean input start. There's no dirty input start, so that's 0. And maybe I just need to put it. I think I had it there. What do I do? Dirty inputs and clean inputs. So what does this mean for, what do I need, the convolution function? This one's gone. I don't think I need this. I'm never going to do that. Do I want that? I do kind of feel like I want that, but I want it in a different function. So what is it? Convolution to 16x16? What the fuck is that? Convolution. So what do I do? See, the thing is, I'm going to get another pool here of 12. All right, so here's what I'm going to do. I do not want to use a big int. Where'd that big int go? Here, let's just go back, bump here down to a number. Okay. Spare bit. Spare it in there. I'm going to call it C bit. And then C bit. Yeah. I'm going to call it the dirty bits. Dirty bits. Yeah, dirty bits. Yeah. Dirty bit count. Dirty. So what is it? The dirty bit. The dirty index, right? What am I doing? I'm siphoning off random number. So what's the point of this? It's a negligible amount of calculations in memory. We just get a free random number. So what do? We, every 60 times that I run this function, the sign bit should be, sorry, every 62 times I run the function, the sign bit, that should be enough to fill up the 64-bit floating point value, because we know that this is going to allow us to create a random value between 0 and 1, excluding 1. So what? Got the dirty indexes of this, the output C. Why am I doing this? All right, I need to close out the function. So what's the problem with this one? problem with this one is that the result is we're going to have a 1x11 matrix result from this convolution function. And it only works on one value. Which would not be a problem if I was doing it with the dirty bit. But then I could actually use this thing like to, I don't know exactly whether or not it's going to be beneficial for me to do this whole extra bit. So to do it negative, the inputs are -1 to 1. I don't know exactly how much that makes sense. First off, we're dealing with the dirty input. Okay. So, secondly, I'm not sure exactly what it is we're going to do with that value. The only thing that I could do is I could do this convolution function with the, well, I could do a convolution function with so every 62 times I generate a random number, I'm going to end up with a random value that I could stick in I don't know if I want this output C. Because then I would need, I mean, I could just take the bits and stick it in there. And then just say, hey, I might just throw this out. I didn't really do any extra CPU work to do this. So let's say count. So what do I do? See, the thing is like I could actually just take the negative 12, or sorry, the negative value, and then I add up the 12 negative values from -1 to positive 12. And so what do I get? What's the min and the max value? Let's say I had -1. Well, almost -1. When I say -1 in this context, I mean can be almost up to 1, like all ones, like 1 less than 1. So I add all 12 of them up, and then what do I get? I get a number that is, I'm going to have to divide, right? I feel like it's kind of like, because I'm losing any data. Like it's not like if I did, let's say I don't do this whole trick that I'm trying to do to generate an extra random number. Okay. I could just store the dirty random number. So let's say I have a random number between -1 and 1. Okay. Let's say I took that sign bit. Does that alter my probability density function? Because I think essentially all that a positive or a negative probability is just the sign bit is just a 50-50, right? Is the sign bit just a 50-50, just a random bit? That's a difficult problem. I don't want to dismiss it because on the surface it sounds like, well, yeah, clearly it's just a random bit, but I don't know. We're dealing with floating point numbers, not like just regular numbers, right? Doesn't really quite work out the way you would think a lot of times. Generally, it's pretty eloquent. Oh, maybe. Hey, now that I'm thinking about the algorithm, let's look at the right, the e to the x. So what am I doing in this algorithm? I'm just multiplying x times x, and then a factorial. Okay. Okay. I don't think that this just isn't the algorithm. First off, I don't think I'm having it. N is an X. Generate. Oh yeah, because I'm not doing that when I generate. I do it when I trash one. I don't know if I'm trashing it. I'm gonna call it. I'm gonna rename it to eject, right? Because I'm already storing it in a buffer, so I don't have to. We'll call it the reject and the eject. Because I don't know if you're gonna trash it. Am I trashing it? What is reject versus eject? Reject. Oh. Oh. Self-burn. Or reject. Don't you eject the reject? So like, let's say the bullet casing gets ejected out. You know, it's not the same as like I got rejected from the bar. What if I got ejected from the bar? So if I got rejected from the bar, that means that the bar rejected me. If I got ejected from the bar, maybe I got beat up in the bar and somebody threw me out of the bar or something. I don't know. I mean, that sounds about right, right? Eject? Reject? What does eject mean? Throw out, to expel, to evict, eject, evict. Let's call it evict. Because it's too close to reject. What we did. what is the other one? Divide. What is it? So there's the top part and the bottom part are different. Okay. So what do we want to do? N per calculation. So what do we have to do? We got to do a state machine. So X and N are now gone for the parameters. But we have a state machine, right? Which means that we got to do where's our next function? There it is. I think that. Maybe I could change the keyboard shortcut real quick. Shouldn't take terribly long. Okay. All right. Now it's not going to minimize my code every time I like try to switch tabs or switch desktops. So I added the sample. And I XOR it with a running XOR. Okay. It should be random. I mean, any random number XORed with a pseudo-random number is a random number. It's the problem is whenever you like have long sequences of these numbers. So we got to think of the XOR thing. Oh shoot! Somebody's here. Hey, Dev. Charka Borti, aloha. Let's see, what do we do? Whenever people drop a chat, I'm usually not paying attention. I'm usually like up on some like long train of thought, and then like I like notice until like later somebody dropped the chat. Oh shoot. where did I just get jumped over to? So we got the here's the trash sample. First off, my indexes just got changed. So index, this one, index. All right. I don't like this index here. This index is forget about that. So sample. So which just the ring bus, the first ring buffer. I'm looking for the word to describe this. With the clean input and output. Wait, so I have output A is always going to be in sync with the clean input. So these are ring buffers, dirty input. This is the value that is, it could be a pseudo-random number. It could be quasi-random. It could be actually random. It could be anything. But then we're going to XOR that with our running XOR from our neural net calculations. It'll go from dirty input to a clean input. So usually we're only going to run half of this neural network. I could actually say oh yeah, I live in Eugene, Oregon. What's it like out here weather-wise? It's rainy right now. We have entered the rainy season. It's cold. So optional output C, optional output D. And then these are going to be for right now I'm making so I have a 64-bit UUID library for optimizing SQL primary key index lookups. Pretty basic. Got a 28-bit timestamp, 8-bit subsecond ticker, 28-bit random source ID, and that's going to be with the MSB asserted. So it's actually like a 27-bit ticker. And then we can do, so that is our temporally unique ID. And then we condense those IDs down to when after the timestamp epoch has expired, which is like a 4-year timestamp epoch, we have to convert our data from our hot ID to our cold ID. So we take a 64-bit random number. We have a CPU-based neural network. We upsample our 64-bit random number up to 128-bit random number optionally. So we're taking a low rank adaptation, a LoRA, probably heard of that. It's very popular with like all the big like machine learning, like LLMs, diffusion models. They're all using LoRAs. So LoRA, basically what you do is you take two one-dimensional matrices or sorry, n-dimensional matrices by n transpose, and then you multiply them together and you make a square matrix out of that. And then this becomes an offset that you use to offset your neural net values. So it's like a dimensional reduction analysis. So what I'm doing, what I'm just about to start putting in, for this one's for a quad LoRa split. So the quad LoRa split, we're doing a dual LoRa split. So we're taking the n by n matrix, running it through the neural network. We cut that in half diagonally. And then what we end up with is each layer of the neural network gets one less neuron on it. And so it's like a dimensional reduction from each layer of the neural network. And then each layer of the neural network is an abstract function. So we're taking a sliding window convolution function of a 3x3 determinant of a matrix sliding over our clean inputs and our output AB. And then we also have output. Now, output CD, we would be taking our LoRa and splitting it up 4 ways instead of just splitting it in half diagonally. And so that I haven't really put a whole lot into. So this is going to require maybe another determinant, maybe what, a 5x5. Cybersecurity, I'm my main API I developed is script 2. It's C++. It's like a C++ standard library replacement based off of this contiguous data specification called it's a script specification, and then it contains the automaton SCII data specification, which has like a 16-bit pattern of, we have 8,000 different contiguous data types in the bit pattern that I have in the API, and then you can make custom types. We have context specific types. And so this API is in TypeScript, but it is married with the C++ version. The C++ version is like the official spec. And then the TypeScript, I'm going TypeScript first because we're running it on web servers. So if you ask me, it just makes sense. Either Python or TypeScript would work for might have to switch over to Python here a little bit. But yeah, security is a nightmare for sure. We're taking dirty inputs from users that could be potentially malicious, trying to poison our neural network. So I don't think it's a problem because we have, in doing a CPU-based neural network, anytime I do a division instruction, I XOR, a running XOR. So I got a really good pseudo-random number generator going on that it doesn't matter really. I could just take the XORed inputs. But this whole project kind of came about from the idea of taking, having the web client develop or do the random number generation and then pass it over to the server. And then, there's I do Python, C++, TypeScript, and then that's pretty much it. I did Java and C# back in the day. All right, so yeah, and then once I realized, I'm like, wait a minute, I'm taking dirty numbers from untrusted clients. Like, I need some sort of way, like if these numbers that they're giving me are poisoned, like if they're trying to do some UUID hacking or something else, if we would, other people don't, like, if you're going to make something that's not secure, like, you should probably keep it to yourself because other people don't really know exactly how to, like, deal with the security. So you're kind of like hurting them. So I'm this project kind of evolved because I'm like, realized it's reckless for me to just like generate random numbers from random clients connecting to my web server. All right, but I got to do. So the exponent calculations, I load. I got x, and then I got the factorial on the bottom. What is n? N is the I is my iteration. N is, oops. So the one on the bottom is the factorial. So I need a factorial. Factorial. How many years? I started programming in 2003. I wish I would have started earlier, but my friends were doing the assembly programming for Super Nintendo back in the day, but I didn't get into it till later, and then a lot of bad stuff happened. I mean, I'm sure being in India, your guys' legal system's way worse. We had the war on drugs, and so a lot of people, yeah, it was kind of ridiculous. America shot themselves in the foot with the war on drugs. They destroyed our economy. Like they created this toxic hip hop culture here in America, and like people were just partying too much, going to raves, nonstop raving. You just can't do that. Now China's, they're taking over. It's like, what are we gonna do? So for each iteration through the loop, I need to. Oh yeah. So wait, this is the cool thing about this. So this is a CPU-based neural network, right? So it's like we don't do it the fast way. We got a state machine to where I am going to generate a random number. I'm going to be utilizing the pseudo-random number, and we basically just do some statistics to determine that it's forms a bell curve. So we take what you do is you take 12 numbers either through 0 through 1, or you can do -1 to 1. You add them up. You subtract the mean. So that would be like if I had added up 12 samples, 0 through 1, I get 12. So then I'm going to divide that by 12. Well, then you have to plus. You can recenter that around. There's two ways to generate the random number. There's -1 to 1. So I'm doing a -1 to 1 method because of something, the polar rejection. So this is why I generate the numbers -1 to 1, is because I can use this Marsagelia. So you take your pseudo-random numbers, and then you do this polar rejection test, because when we use values -1 to a +1, this is going to allow us to utilize our sine and cosine tricks with our trigonometry in order to reject values that basically they need to add up to 100% probability. And so you're using the unit circle. I do believe this is the fastest way to generate a random number. What does starry mean? I don't know what starry means. All right, so this is, and I'm glad I looked at that because I forgot why I generated values -1 through 1. So the problem is that we need to go through you want to start coding. how did I start? I started making my own graphics engine, and then that's how I first started doing linear algebra. I mean, I started out as a high school dropout. I never graduated engineering school. I did a double major and then I ran out of money. I got almost all the way through it. So functionally I've got it, but learning game development is one of the most difficult things. Like anything related to statistics is very difficult. Machine learning, like using AI to build something, not difficult. Requires somebody who like understands that there's like a need that could be met with AI. But I'd say any sort of project where you can calculate something, if you could like calculate, use an algorithm to calculate anything that you find to be interesting, calculating digits of pi, calculating, searching for some sort of number that is like infamous, implementing a research paper. I would highly recommend just going and looking through the research papers on the machine learning and just looking at what they have in there. You probably would be like, what the hell is this? I have no idea what you're talking about. Oh, okay. So, but I have a thing that I'm doing. We're doing shoot, what was I doing? Oh yeah, the exponent, right. So the factorial is this factorial. Wait, let's do next. Oh, wait, hold on. Probably don't need to do that. I actually do want to do this because we're taking this. So this one is the so x. This is x times x. Running total. Wait. X. This is the X and then N. What is the do I have to store x and then the running value of x. The factorial, I can just wait. Oh, so I need a running factorial and I need a running exponent. Let's do this. Let's call this a running factorial, running exponent. I need a factorial and a running factorial exponent and a running exponent. Running factorial value for running calculation. Running factorial stored. Wait. Wait, so we got we're doing a factorial, right? So we go 2 times 3, 2 times 3 times 4. So we have the factorial each time it goes down, and then the exponent. We don't even keep track of the exponent, do we? So I think I just renamed the exponent to a wait. No, I have to keep track of the exponent and then the running exponent too. Exponent value. Okay, sure. X. What is the x? This is the exponent, right? Oh, right. So exponent is, what is n? N is the value that I'm looking for, right? X is the value that X is like the f of x, right? I don't know why this is like taking me so long to figure this out. X is the exponent. I'm going to just change this to the exponent is running x. X and running x. Sure. No, x is constant. Hey, don't eat the wall. My bunny's trying to eat the wall. They weren't so cute, I'd eat them. It's banging around outside. I might have to go check up on it. Every once in a while, the rabbits get out. I can't say it's not entertaining to try to catch them. Because it is actually kind of entertaining. So what is the, so the running x equals, n is what? N is I. N factorial, right? So, I just need to name it n. So n factorial, so I keep track of n. Wait, hold on. X to the n. Let's think about this. Oh, it's e to the x, right? Hey, stop that. No. No. Oh, every once in a while, I hear him chomping on the wood. I just feel so retarded with this. So, x to the n. So it's f of x. And then n is what? And is n like the number of times that I'm going? Oh yeah, n is in like the number of times through the loop. Sorry, it's Ronnie, you need to stop. Stop. Just chomping the wood. If most people would tolerate these rabbits, dude, they'd probably eat them a long time ago, dude. Like you're chopping on my walls, bunny soup. How many attacks do I know? I don't really. I'm not a hacker. I mean, I probably could figure out hacks pretty quick, but we're just mainly looking at like neural network poisoning, where people are trying to like input in values to make it specifically output in values. I'm just using I don't think that it really matters for me, because for me, like, there's poisoned outputs are like they don't match a normal distribution. They're like not a bell curve. What am I making? This is a neural network based random number generator. It's called the low rank recurrent convolutional random number generator, aka LORC, LORRC. I'm kind of winging it. I invented this. This is kind of my little thing, but yeah, you know, I only use the neural network to generate output values when I don't get a normal distribution out of my pseudo-random number generator. Factorial x running x, factorial, and then no, this one's capital F, because I'm a chimera case guy, dude. Running factorial. So the running factorial is, because this is a state machine base, thing. It's not a normal one. So the running factorial is I'm not making any money off of this. I wish I was making money off of this. I hope to make money off of my database product. I'm building a Postgres extension and so we do like a in-memory data store, like read it, and we have the 64-bit UUID generator. So, you know, we're not just a, Postgres extension that does nothing. We hopefully have our own auth system. Factorial next. So what do I do? Running factorial. I think I have too many intermediate values here. Maybe I just need to just multiply those, right? Running factorial times factorial. So I invented the world's fastest integer to string algorithm. It's in my script2 API on GitHub. I've got a research paper in the wiki there, and so I am attempting to break another world record with the fastest random number generator. What? Running for factorial. So wait, factorial is supposed to be the n. So what am I plugging into my function? It's e to the x, right? E to the x equals. But I'm going up to a target, right? And then n is. This is your calculus 3 stuff. Yeah, my integer to string algorithm called Puff. It uses some discrete mathematics in order to eliminate over half of the division instructions. It's pretty interesting. Basically, first off I bit shifted to find the length of the string, and I grouped the digits in groups of. I converted them in groups of 2 at a time, and when I folded them up in a specific way, it eliminated over half the division instructions. It's like basically it's a manual modulo approach. Instead of using the modulo function like you normally would do, I did that by hand and then organized them a certain way. And it's a pretty cool little algorithm. It's undeniably the fastest one. Mathematically proven. But yeah, now I got to do get the faster random number generator, and then you know, might stand a chance competing, but it's a rough market, man. There's a lot of like competition, and they're really smart, and they have way more money than me. Like I'm a chump compared to these guys, right? um, so n is the number of times. I think so. This is n, right? So I take n. N is the comparison value. So if we go up to n, hold on. Do I keep track of n? I'm so confused. So I need to do this a certain number of times. So I'm going to, I thought n was, Bunny needs to stop. Stop. Well, she just won't stop chewing on. I don't think AI will replace my job. First off, I run a news business, so like I'm going to be using this to be running my news app. So if I replaced me with AI, it would allow me to do my other job. So I think that pattern is not going to be unique to me. I do believe that you're just going to have to use AI in order to do something else. We'll just transition. I'm sorry, this bunny is eating the wall. Ah, well. Yeah, non-stop, dude. So we just go back and chew again because now she knows she gets interaction from me whenever she chews the wall. So n per calculation. Doing it the wrong way. Wait, this is just not what I want to do. I don't. Pressing the wrong button on the keyboard. So I need to do a while. And say that n, hold on, let m, or sorry, constant m equals n plus n per trigger. Oh, then I need to do something. I need to like exit. So if what m is greater than or equal, if m is greater than n per trigger, then I need to change state. So I don't have the state machine set up. So what is the... So I need to do... I need to loop through each neural net value, and then I got to calculate e to the x for that neural net value. So that means that I'm going to need an intermediate storage. The convolution out is not really what I'm looking for. LoRA history, convolutional output. This code gets run when the neural network is activated after the convolution function. So we're going to have a scratch pad. E to the x. I'll just call this e to the x. for the LoRA value. Wait, hold on. This is a memory map. So this is a TypeScript first API. I'm not using Python. I could use Python. I'm good at machine learning in Python, but I need to like make it run on web servers as fast as possible. So I'm just taking an array of 64-bit numbers in TypeScript, and isn't this a LoRA? So here's my n LoRA e to the n. I studied engineering at Portland State University in Oregon in the United States. They have Intel there, so a lot of my teachers taught at Intel, and they're a lot smarter than me. I'm not that smart, dude. I just got taught by people who were smart. I don't like Scratchpad is okay. N e to the x. I don't know what to say. So I need I have an n by n dimensional LoRA matrix, and I only need n neural net input. So I'm like n e to the x. I think I can do this. So I could do any x. I could just call it any x. That sounds good to me. Stop it. N times e to the x, running calculation, number of e to the x calculations required. No. So n is defined in this particular case as a n by n LoRA matrix. So where's the LoRA dimensions? Getting complicated. LoRA dimension. Don't really have scratch LoRA activation. There she goes again. Gonna go on chewing from one thing to another. I don't think she has enough chew toys. Maybe I need sticks for her in there or something. I don't know. Activation count. Am I using this anymore? I think I've moved past that. Checkpoint target. What is checkpoint target? So the state is basically I chop up all my neural net calculations where each section that requires division is going to, each thing that's going to have a division, you're going to, sadly, there's no money in anything like this. All this kind of stuff is like, it's either some company is going to provide it for free because a lot of it's just computer science. Like, this is like a multi-day project. This isn't like maybe a 1 week project. I think I've been doing it some number of days. Like if you know what you're doing, but building something like this from scratch is going to take a week. So the value of this is definitely not, there's no value. Or else I wouldn't be doing it on YouTube, for sure. Now, being able to generate UUIDs, knowing the different ways of generating UUIDs, when you would use what particular kind of UUID, that's universally unique ID, this is going to be something that would help you out a lot in life if you're trying to get into programming, because, I mean, you got like your SQL databases, and if you use a 64-bit UUID, that's going to be, for your primary key, is going to be the best thing that you can do. For something like Redis, you'd use 128-bit or maybe like a 20-byte UUID. And that's just like, they just use random numbers for those. But there's benefits to, like, my format stores the timestamp with my thing. So like that can be slightly problematic because you don't have like a way to search through by timestamp if you want to be anonymous. But I kind of designed it to be that way. If you want it to be anonymous, I'm just not going to make it searchable because, I mean, I'm going to have it so you could search a different way. So my technique is not like a one size fits all. My technique is going to be fast for most things, but there's no one size fits all. Yeah, I wish there was money to be made and stuff like this. That'd be nice, you know. You got to put together like a platform that's got like, you got to get people they need to rely on you. You need to do something better than everybody else. And then once they rely on you, then you can start building a pipeline to your sales funnel. But it requires trust. Trust is built through confidence and competence. So, you know, they got to trust you, and then they got to know that you're competent and that your product's going to be coming through for them. And that's like a rich man's game right there. That's like, you got to be pretty clever to be able to extract money from open source software. It is, anybody who is able to get money from open source software, it's actually kind of impressive. It's like finding water in the desert. And a lot of people, they sacrifice years of their life trying to do some open source, you know, maybe they're trying to get a job or whatever, and they just make more noise. Maybe they're not helping like with the current open source. I mean, it's healthy to make your own projects, but the problem with making your own project is there's probably a better one out there that you could have helped out with, and you're like making noise for everybody to deal with. It's like, APIs are just, it's like, I've been trying to make money off of APIs for a long time, and you need a service. You have to have something that you have to have like a walled off garden that makes it so that your competitors can stay out. And generally this is like, you know, a lot of times this is done through like server-side rendering, or like a database that they need access to and they need to get through you. Or maybe you have like you're hosting something, and then like you have an open source API. People use your API because they know and they have confidence and competence. They have confidence in your competence, and then you can build, you know, like you start out, here's the free stuff, and then if you want to build up your business, you know, there's eventually there's going to be stuff that your business needs, and then this is where you can make money with APIs. But it is a rich man's game. And I'm a poor man, so I recognize that it's a rich man's game, because it's not like, it's like, you know, trying to compete with Google. You're competing with people who have like the best computer scientists, whatever you could think of. They probably got way better. They've probably got 20 of those mothballed in the closet ready to go. They probably had meetings with like people they paid $20,000 to just for one meeting, just so that they can figure out something about what it is. Like those guys are nuts. You know, you got to compete where you can compete. Basically, you know, I'm able to compete with my integer to string algorithm, now with my random number generator, with my UUID API, and then how do I monetize it? I don't know. You know. So the NEX is NEX. Look through here. Factorial. Oops. While n is less than m. And then I guess we're going to check. I could check 3 times. I think it's okay if I just check once. So what are we doing? The n number per calculation. That doesn't change. We change this. N is equal to 0. This dot running factorial is equal to 0. This dot x is equal to 0, right? No, x is why is it so confusing? It's just such a simple algorithm. So I need to keep up track of the factorial, because I calculate that through each iteration. And I just need to keep track of what? So the exponent, so these e to the x, what am I doing with the e to the x? Aren't I doing with the neural network calculation? I need to look at what are we looking at with the neural network? Is it x to the n? I think I just need to stop paying attention to this. This is just like math speak. This stuff over here, like this is really, it's just, this is the only thing that matters. This is just kind of, this makes my head hurt when I think about this, because it's like, this is the algorithm. This is how we represent the algorithm in math terms. And that's just not really the same thing. Because all I'm doing here is when I'm keeping track of the n, right? So the x value, I mean, it could be whatever. The x is the x over here. All right. And then in the loop, I'm just keeping track of what x originally was. So let's say x was originally like 2. It's like e to the e squared. Okay. So I start out with 2 here. So this is 1 plus 2. This is going to be 3 right here. And then here, now we got, this would be 4 divided by 2 plus 8 divided by 6, dot, dot, dot. So n is the number of iterations basically through the loop. And this thing is, I don't really have to pay for this. So n is the iterations through the loop. And this dot running factorial equals running factorial this dot n equals n this dot running. I'm a little bit OCD with things being in alphabetical order. Wait. This factorial. Wait, I don't really pay attention to this, do I? No, the factorial just gets incremented by 1, right? Wait, the factorial is what? Oh, isn't that n? Right, so this is where my brain is breaking. So we're converting from n into this thing, and then like my brain is for some reason just like being retarded. No, this is a running x. Wait, no, running x, I calculate, right? So it's running x, because each time I iterate through times equals x. And then we do running x here. Running factorial, I just did that, right? Wait. So what happens when I do e to the x? Where do I calculate next at? I'll put ace there. This is at 412. Wait, that's dirty inputs. Yeah, dirty inputs is 0. I just did that robotically, unfortunately. A, B star is now 3. And then this is 4. I might get rid of the dirty sample storage. Right now, wait, hold on. Now we need the con. Oh, did this. Now we'll do a clean input. What are we ejecting? Eject. I'll put A star. Okay, so here's the other problem that I have. I got the dirty, I got the clean. So from here now I need to do secrets to me staying so focused is I got in over my head. I started making MIDI controllers, like with like touchscreen interfaces, and then the more I learned, I just I just assumed you could just like make this stuff, but then the more I learned, I realized like everywhere you look, you turn over a stone, and there's like this giant mountain of like really interesting computer science and mathematics, and I'm pretty poor actually, so my startup has not been doing good. So at this point in time, I think I have some cost fallacy. So I'm probably not the best person to imitate on that. Hey, you need to stop that. All right. But yeah, just interest in it. I studied AI in university, and I never really used it, and it got a lot more advanced, and there's a lot of things that I don't know. So, you know, this project's helping me to build something that's not terribly complicated. You know, I'm not opening up like a book to like do this. I'm doing it based off of the first principles that I know, that I've studied over and over and over and over and over and over again, until eventually at some point in time it's just like watching videos for entertainment. Like I know what's going to be in the video. I'm just watching it to see how good they did, or like maybe watch it again. So I eject. What do I eject? I eject one clean sample, and then I'm just gonna create one. We're gonna call this a probability. I think that my biggest mistake is not getting through the classes that I needed to get through as fast as I could, allowing it to just drag on and on and on and on, and then just justifying just doing the same thing over and over again. I think you need to do multiple things in a day, and you need to do them faster. You know, it's like I can see the difference between me and the young guys. The young guys are doing it faster than me, and that's not acceptable. Like, I'm getting older, I got to compete with these guys. So, yeah, I think the mistakes in general, you should look at it through the perspective of somebody who's my age. I'm 43, and the problems that I'm going to be having and facing, which is age discrimination. Uh, you know, the women can't have babies. You know, these are, you know, life problems. Yeah, I wish I would have networked more. I think that networking more is it's people haven't been doing it because we're online, and it's just so important for us to keep up on it. And as you get older, you know, we allow our network to fade, especially if both the husband and wife go downhill. You know, that can be a major bummer. What am I ejecting? I'm just ejecting. This is going to be samples. So we want to take the input sample and sample equals client sample. We're going to say this is the dirty probability. Dirty meaning it is not clean. Probability. It's not like known to be a good probability. Oh gosh, I can't spell probability. If I could do the same, if I could repeat, I would have made myself I would have focused on making myself more attractive to women when I was younger. I think everything else I, I'm happy with me and my achievements. I'm not happy, of course, with being broke. But America is a great place to be broke in. I'm absolutely not happy personally that I didn't take as good care of my face and my hair. I wish I would have worn nicer clothes. But I'm happy with what I'm doing. I think that it is undeniably interesting. I don't think that most people would put in enough time to actually do the work that's required to learn all of this stuff. I got stuck doing it. I just had to do it because I was broke and I didn't have any other option. I think as an Indian, you'd probably understand where I'm coming from. This is probably like you're like, oh, he's one of us. Oh, yeah. In America, people are really superficial though. Like I can't tell you how many. I mean, it's you could. It's like the easiest way to explain it is that the leftists, the liberals, the Democrats in America are they've become like the Brahmin class. Essentially, that's what they've done. It's and then they're in with they're the Islamo left. The liberals they end up getting they end up being friends with the Muslims. They're like strange bedfellows because they both hate the Christians, and it's yeah, it has become a little bit more like it's become like a caste system here in the U.S. You know, because most Democrats and liberals live in big cities because in the countryside you can't really have socialism. You know, like you need to like generate the stuff that we need to live off of, and you can't really do that with socialism. But in a big city, they can afford to be socialists. So the socialists here in the big city are like they're they're very hateful. They're like Brahmin. And then all of the people who live out in the rural area they support the Republicans, and so the people in the city they hate the people out in the countryside who are like the farmers. So it's like they've made a caste system with like the farmers at the bottom, and it's like it's so bizarre because they don't even recognize what they did. You know, I studied Hinduism in India in college, so I recognized the the caste system because you got these elites in America that are on social media. Like maybe they have like 100,000 million followers on their Instagram or their Twitter, and it's like they're like Brahmin class. It's just so weird. It's like but they're like failing epically because they're like people don't like them because they're fake and superficial, and it's just normal people just aren't like that. But like in a big city, there's enough of them to where they can make it seem like it's like that. It's pretty weird. They're losing though. I mean, nobody wants to be in a caste system at the bottom. Sample. So what am I doing? Didn't I like the dirty probability? It's ejected, and then do I do anything with that? So the clean probability. So what do? I add up the 12 random numbers. Okay. I think this thing is messing me up. This third one that I added. So the clean input. Wait. This one's bad. Clean input, dirty input. And then when we do, aloha, thank you for watching my live stream, man. It means a lot. I hope the Live Coding Alliance is going to have more live coding. It'll be more interesting too. This is probably, the least interesting it'll be. But yeah, I hope you have a good night. It was good chatting with you, bud. Dirty probability. Dirty. What they took the clean input out. So here's the clean input. Start. Okay. Maybe I like that better. Okay, so we get the random number. So we add up the last 11. Oh, wait. Hold on. What am I doing? I figured I should just load all these values and then just subtract the eject. Oh, right. So the eject is the last clean value. We ejected. We summed them all up because it was quicker than going through 2 for loops. We just subtracted the eject. I haven't verified that that's faster, but kind of seems legit, right? Dirty probability. Running XOR. I don't know if I should flip these bits whenever I XOR. Maybe I could flip the bits and add 1. I mean, it would make sense, right? Whenever I use it, flipping the bits and add 1. Document that. I mean, inverting and add 1. I mean, it's as good as anything else. It's moreover I could do random things until I'm blue in the face and I could have a seizure just doing random things, dude. But that's not really going to help me out. I think that this, each time I use it, inverting it and adding 1. I mean, it's not a bad strategy. It's not. It's all going to be coming down to a subset of a sequence. That's what it really comes down to. And so this sequence is, there's an infinite number of them. I could just spaz out. I could have a seizure just thinking about how many different sequences of random numbers there are. Yeah. I gotta pee. I'm gonna go grab an energy drink and pee. All right. So I need to step through this thing. Took our probability. And then what are we going to do? Divide by 12, right? Yeah. I really like the AI code generation, dude. Okay. So here's a random value between I'm interested to see if somebody can poison it by putting in 0. I'm going to put an OR for I'm gonna comment this out. I don't know if I'm gonna need that. I mean, hey, stop that. Right now she knows she can get my attention by chewing on the wall. Oh God. Oh. Here's my random. All right, so what's the next step? The next step is you do the so you take the sampling, the random sampling from the probability distribution, right? So what do I have to do? To get my standard deviation, I'm going to shoot. Oh yeah, I gotta subtract it from the sample. So shouldn't I be doing that? I subtract it from the sample in the square, right? Yeah, I'm starting to start up to do 3D printed bunny and small animal shelters. Cause I'm tired of this. I'm tired of this bunny chewing up my walls. Shoot, didn't notice your chat. Yeah, next time I'm gonna be doing it is I'm probably gonna be trying to do every day. I have other channels and I'm trying to get around to them. Yeah. Yeah, I have one channel per GitHub organization. I have a lot of GitHub organizations, but not a lot of subscribers. You know, but I'll have more products, more like stuff you can actually use here pretty soon. What do I need to do when I'm sampling these things up? I need to take the okay. So what do I need to do? I need to calculate the mean squared error when I'm doing this, right? So I take the um, I'm just doing all this. I haven't took a statistics class in so long. How do I calculate a standard deviation? You like subtract the sample, right, from so I take the standard deviation. Wait, hold on. This has to be done after random plus equals. So standard deviation plus equals. Oh wait, hold on. Wait, hold on. Dirty probability. Oh, I need my clean probability. So what do I need? I need a clean probability. Wait. Wait, hold on. I need a dirty clean probability. Wait, no. Sugar, you need to stop that. What do you do? She's like, once she figured out that she could start chewing on the wall and she gets me to come over and pay attention to her, dude. Oh, now it's like nonstop, dude. It's just a little chomp. And she knows what she's doing, dude, because I can see her. She's looking at me. She's like, and he'll come get me now. That's a dysfunctional pet relationship right there. So what do we got to do? Running XOR. running naked XOR. Oh yeah, my camera. Oh yeah, my coffee. Yeah, I gotta go get the coffee. I'll be right back. I'll get the coffee and then I'll be back, like ready to go for another hour. Okay. All right, I'm back. Probably nobody watching anymore, but it's all good, dude. Shoot, I guess the all right. I just need one more minute now. I am just about ready to go to town on this state machine. I know exactly what's going on with the algorithm now at this point in time. It's actually surprising how little amount of code there is in a neural network. Like, I mean, I've hacked this stuff up from scratch without even looking at any sort of code or anything, except for like a couple of lines of Python. Uh, but the you can do that stuff by hand, but then when it gets bigger, then it like you need the machine learning libraries, right? But like a small neural network, I mean, your CPU is going to run it just as fast as a GPU. We're using 64-bit numbers though. Huh. Oh. Okay. Bunnies are fighting outside. I don't know. I mean, I could save these, but I don't really need to, so I probably shouldn't. This is this is 8 bits, and then this is 7 is 3 asserted bits, right? Okay. Running X or Mantissa equal running or let's just rename this to or Mantissa. Wait, no. Uh, looks like sign Mantissa. No. I'm sorry. What is this? This is not meant to. This is an exponent. Huh? Oh, okay. So running or something. Is that what I'm doing? So what do we do? I'll just rename the running XR. Too complicated. It's good. Intermediate. Did I just figure that out? So the clean probability is what? So what is the clean? All of the exponents are supposed to be -1. So what do I need to do? Check the exponent bit up here. All right, constant, dirty exponent equal 30 exponent f dirty exponent equal to -1. I'm okay with running this code because, I mean, it shouldn't, even if there's an error, if that was an error, I don't care. Better to have like a easier to understand thing. The exponent has to be -1 because let's say the exponent is 0. Okay. If the exponent is 0, that means the number is an integer. All right. We're talking JavaScript here. We're in TypeScript. Same applies for Python. Anything that's an IEEE 754 floating point number. All right. So the dirty exponent has to be -1 because IEEE 754 is a double precision format. We got this exponent. So this thing is has a hidden bit. All right. So if it's an integer, this sign bit is going to be a 0 right here. And then the thing is going to be an integer. The thing behaves as an integer. Just like a regular int that you would find. It doesn't start behaving like a floating point number until the exponent is non-zero. At that point in time, there's a hidden bit. And the hidden bit is all the way up over here, bit 52. The bit 52 is always 1, right? And then this exponent shifts whatever it is into place. Yeah. So it's like whatever the hidden bit in Mantissa, shift left or right exponent, because we're in base 2. So this turns into, this will be a number, and you could represent it in hex or binary or base 12 if you really want to. Knock yourself out. Kind of weird, but you do you, bro. Right? So this is just like if you see the number like 3.14 times 10 to the third, right? So we just shift the decimal places over. Same thing with the binary, the floating point. Not very difficult to understand. It's a pretty good format. We got. So what does that mean? So when the exponent is -1, that means that we're shifting it, making it smaller, just like a 2 times 10 to the -3 is 0.002. So we have, instead, we have 1 point mantissa, shift, left or right. So let us say mantissa is all 1s. All right. The fraction bits that are called the mantissa. So the fraction bits are 1 point mantissa, and then you shift. So if they're all 1, that value is almost 2. Okay. So if it's 0, that means it's, if the exponent is say 0. Let me think about this. I think I said something wrong. No, yeah, the exponent means 0, right? What does the exponent have to be? For it to be an integer, wouldn't it have to be 52, right? No. How do they get it so it's like behaves as a Why would you do that? This is just such an odd way to write it. Are they doing it because that's just a weird way to write it? But it's legit, it just looks funny? Okay, I'm a little bit confused. When does the float act like an integer? Now, back in the day, this is the quirk that like breaks your floating point number format. Is how they. So what is it like? Is exactly. See, the problem. This is the sentence that's the make it or break it. Is when the consecutive representation of the numbers aren't one, then it breaks all of the math. So back before they used to have this floating point format, they used to do it in different ways because you could see, because like my brain broke like whenever I realized that like what I said wasn't completely true. Um, or yeah, because it was any exponent over 52, is it? And that's I don't under see. I just don't understand that. Maybe it's like a trade off because logically it's not consistent. So you would think it would just be like the hidden bit mantissa, and then but no, if the exponent is over 52, there's no more hidden bit. Is that what I'm reading? So the hidden bit is specifically for when you're representing values that are less than 2 to the 52nd. And then, I mean, that would make it a lot easier to parse because there's like a lot of different combinations of ways to make the same number. And then that causes problems because, you have to like utilize the like range. You can't just be like, oh, does it equal 0? You have to be like, is it in the range of 0 plus? Hold on, 0 is not a good one because I think that would be in hardware too. But let's say if the point is, you can't just say is a point equal to x. You have to say like is a point greater than x minus delta and less than x plus delta. Right? You got like a range that you're looking for because there's multiple representations. So this is the thing that's gonna make my thing actually work now. That apparently I've been telling people the wrong thing, but it's so complicated. I don't think that people would be greater than or equal to 52. Wait, hold on. What am I doing? What am I saying? What am I trying to do with the dirty exponent? Why? I want all of my numbers to be in the same range. So I want all of the input exponents to be the same. I want that. Is that what I need? Because you got to think about this from a standpoint of somebody is trying to poison my neural network. Right. So if you were going to poison my neural network, how would you go about doing it? You would make it so that the determinant of the numbers would not yield a valid bit representation in floating point. That is very tricky right there. But as long as all the exponents are the same, like let's say everybody who gives me a number, like it has to be that the exponent is equal to 52. Let's look at this dirty exponent value. Dirty exponent start. Does that make sense? Start value. Dirty exponent start. That's not what I want to say. What IEEE 754 double proof. I'm just gonna say DP. DP because you know you like the double penetration. Especially open source, right? No source available, straight MIT license. It's not gay license, right? DP, director of photography. If you've been to Burning Man and you're not into videography and you hear DP, you think double penetration, right? If you are into videography, you see DP, You think director of photography. um, Boy, that's long. Woo! And what does this mean? See, the thing that's really breaking my brain right now is I always thought that the floating point number always stored the decimal places. But now that I think about it, let's say you had a value that's like using all 52 mantissa bits, right? Okay. So where do you store those fractional bits? Oh God. I guess we don't even store them the whole time. Huh. I just assumed that we just like stored them as a floating point number. And I didn't really think too much into it. You know, that was like the extent of my thought process of, oh yeah, you just store it, it's just a float. Right? We captured the decimal places, but I'm like, where are you capturing the decimal places at? Right? There's more bits, bro. I mean, like, once you're up over that if the exponent is over 52, right? It's just an integer, and then you shift that integer up and down. So there's no more hidden bit after that. But it's like, you know, all the like values less than 1, no, there's just no room to store it in the float. So if you would need to do that, you would have to use like a 128-bit floating point number. I did not know that. I thought I knew this IEEE 754 better than I do, I guess. So I think whenever I'm doing this constructor, I need, now that I think about it, or max probability. Here it is. So we need to do dirty exponents not equal to let's call it a clean exponent value. Because let me think about this. So we're trying to generate a number a random number between 0 and 1. Okay. So intermediate steps, we would want to use our double precision. I'm just going to call it a clean exponent. So when you submit a random number to me, I want that exponent to be exact what I want it to be. So this is the thing I like about this is that it's like a litmus test. So let's say you're connecting to my server and you are a hacker. Let's say you're like an AI bot that like hacked my server and you just don't know what it is that you're even looking at. You know, you're figuring it out with like a machine learning algorithm. All right, so um, I don't think that it's going to be. Yeah, I'm just going to enforce that the exponent has to be what 51, because everything 52 and greater. So we have 52 mantissa bits, right? So let's shift those mantissa bits over 52. And what do you get? You get the hidden bit, right? You're right. And you're left at the hidden bit. I don't know exactly why they're not using the hidden bit when it's over a certain value, but I'm glad that they're not because none of my code would work. Shoot. Like, oh my God. Thank God. So it also allows me to maximize the randomness of the bits because as long as I know that all of the exponents are the same, I do. Oh shit. That's the thing. I'm a little I hope I don't get up to the point where I'm putting the neural network together and the math doesn't work out. But I'm reasonably sure, you know, when we split up this n by n times n transpose LoRA matrix, LoRA, low rank adaptation, then what do we get? We split that in half. And so we could train this neural network as if it's fully connected. And I'm just assuming that we can split it in half. And I have no idea if anybody has ever tried to split a LoRA in half. I would like to ask ChatGPT about that. Now do they have... Dude, that's just not okay. So like the Copilot is like adding things in it that make it so I just absolutely could not display Copilot on my live stream because I mean there's nothing, I have nothing embarrassing on my computer. It's all work shit, but you never know. You absolutely never know. It could be a, you know, just something, you know, doxing information or something. It's just recklessly irresponsible for them to have that. But I guess you just don't use Copilot, right? I guess I gotta... What do I use? Can I do it in... How do I do that in... You do Control Shift X. Oh no! Control Shift X, and then it does what? No. Oh, the X is the extension, and oh, it's stupid thing. So Control Enter is the Copilot menu. Control Enter. What was that? Okay, spit out something. It's wrong answer. Control I. There it is. Oh shoot! But it's gonna mess up all my cameras, dude. I need my app. All right. What do I do? What am I asking? Yeah, I think it's definitely best to do the probability for the random numbers, forcing the exponent to be 51. Oh, right. I wasn't I gonna like do something? How do I access to the how do I do that? Damn. I never finished my class, dude. It's always a constant bugaboo when you don't finish the whole class, dude. It's like you gotta grok that shit, dude. It's just best to do like one thing at a time and grok it. And how do I make a new auto? Can I do Gemini? Is it Gemini 3 that's the like oh my god, what just happened? Gotta be Gemini 3. Do they have it? Yeah. Yeah, I can use Gemini 3. At least I am thankful that the AI companies are being open because it's so nice to be able to play with all of them. I guess that's why they're doing it. This is apparently this 3 Pro. This is what's up, dude. Let's try it out. So let's see what do we got? LoRA random number generator. So how can I use AI to help me out with this? No, I was looking for something, dude, and then now I'm stupid. Oh, damn it. Son of a bee's knees. Shit, I guess I'll just I lost my entire train of thought trying to get that Copilot up and running. This is the first time I've actually been live coding decently for a long time, man. It's been a long time. I've been like having really bad anxiety, and my keyboard shortcuts getting zapped was like a complete showstopper. And stream effects going paid for GNU software. Like, dude, what the hell? I mean, is it still technically GNU software if you like charge them to build it, but you give them the source code? I think it is. I think you're allowed to sell GNU licensed source code, even if you don't own it. Like if you build some GNU source code for somebody, you can just sell it, dude. If somebody's going to give you money, I think that's kind of cool. I mean, I want to sell something I like didn't even have to like make money off of it if I could. You just can't like use it in any closed source stuff. It's like, you know, it's kind of communist, but you know, GNU is communism, but it's like shisty competitive communism, right? GNU is communism. Shit, son. What the fuck am I doing? What do I need to check exponent? So the output exponent, is it always supposed to be what do I do? So generating random bits in the mantissa is different than generating a random exponent. So the random exponent, I don't know like exactly how that works out. Because I thought I knew IEEE 754 a little bit better than I did. Thankfully, I noticed the glitch. Like, wait a minute, hold on, that doesn't make any sense. So it's not IEEE 754 isn't like 1 point something 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 or other times 10 times 2 to the negative 1. I thought it was like that. But it's not like that. It's actually just a blob of binary and then shifted over. There's no like one dot. Damn wrist. Oh, hope they're not Craigslist people trying to buy my stuff. Running factorial. Running X. So dirty index. Current index in the dirty bit. In dirty bit. Current index in dirty bits. I don't think I'm using that anymore. The dirty index, I mean, seems like, you know, something my baby mama would use to determine whether or not she should go out tonight. Low blow. I didn't get any lunch. I'm starting to get hungry. My sink's busted though. But I have breakfast. I have a bunch of coffee though, too. So here's the scratch count. I think I just said was the LoRA dimension. So perceptron count. What is this? Sample total. What, so I'm making a new matrix here? No, I'm not. Look at the top. Like, oh, didn't I have to move them back up here? Right. Wait. Start. What is this? I need now like a checkpoint A. Wait. I can't get this from this, actually. Right, so I have to have a dimension count. Oh wait, what am I doing? What is this? I feel like this is like really slow to do it this way. Yeah, I guess I need to group this up so that it's like faster to calculate. So anything related to LoRA needs to go here. I guess it is there. My LoRA velocities are the same dimensions as n. All this stuff is convolution output is n again. Well, it could be n, and then we just waste 2. That's perfectly fine. Wasting 2 is not a bother. Wasting 20, maybe. I start to get irritated. History n. Wait. N. So history n. What is it? Intermediate layer e to the x. Does that make more sense? LoRA layer e to the x. Does that make sense? Layer e to the x is I want it to be like near where I'm doing the calculations in RAM so that I can optimize the memory controller. Or a layer x. Wait. I could just say e to the x calculation. Right. See, this makes the e to the x actually more processor efficient, ironically. Faster to do e to the x than ReLU in this case. That is actually exceptionally interesting. All right, so where are we at in this? I'm just like, I'm kind of a little bit like, I'm not fried in the brain from all the math that I've seen. I'm a little bit like, I'm at the point where I'm starting to like wrap my head around everything, and then so the clean probability is what? So the exponent, the dirty exponent has to be an exact number because we need it to be a full 53 bits, not like 52 bits, but like full 53 of random bits. I need a better name for this. Like, clean probability is like, I would want to reuse that terminology. So a dirty probability, I think, is okay to call this a dirty probability coming in because it's dirty. I don't want to call a probability that has the exponent set to 51. I don't want to call that a clean probability. I want to call it a, like, maybe like an HDR probability, high definition. What am I trying to say? I'm trying to say highest resolution probability with HD, high definition probability, HD. That's okay. I'm okay with saying HD probability. High definition, you know, because it's like we like maximize the amount of data that we have in there by using the hidden bit. Wait, so hold on. So I got the probabilities coming in, and they're going to be positive or negative. Okay. All right. So the exponent bits we know are going to be the exponent bits we know are going to be 51. So wait, what am I outputting? Am I outputting values positive? I want to output values 0 to 1 because I want my neural network. I don't want my neural network focusing on a random bit. It's not productive to have my neural network focusing on generating numbers that are -1 to 1. And while I mean, I could actually just say, I could actually possibly make it so that I could remove the last 2 neurons and replace them with a, well, whatever that function is. Like, okay, so like, let's say I'm outputting numbers -1 to 1. All right, all I have to do is just in the output stage, my last neurons are basically scaling the value from 0 to 1 to, like, it's just multiplying that by 2 and then subtracting 1. Right? But what happens when I multiply by 2 and I subtract 1, though? Right? Multiply by 2 and then I subtracted 1. I don't lose any information, right? But the thing about that I don't like is that the neural network has to learn that. Because we would have, on the very final output, our last 2 neurons would always be scaling, right? Because we would always be multiplying by 2 and dividing by 1. So let's say I know that those 2 numbers are exactly what it's supposed to be. How can I make my LoRA output values that comply with that? Because when we split our LoRA square matrix diagonally, and then we utilize half of the neurons to make a neural network that decreases by 1 neuron, or perceptron, I mean, each layer. What's the benefit of this? The benefit of this, as opposed to having a fully connected layer, is first off, we might be doing dropout layers in the first place, where we're taking some of the values and then taking away the values. So let's look at it from the terms of linear algebra, right? So this should be ringing bat signal. Oh, I forgot my camera's on. Wait just a second. So let's say that I feel like if I wanted to actually do this, I would need to like bust out some math that I'm rusty with and probably didn't get far enough to actually get there. So if I wanted to make 2 of my entries in my LoRA, I need to draw this. Now my stupid document camera. I'm going to try to get the document camera on for a second. It's going to take me a second. Oh, I really wish that I had not done that. The keyboard shortcuts disappearing for me was a nightmare. Still dealing with it. Mm-hmm. Document. Oh, shoot. All of my keyboard shortcuts are gone. Switch this thing. So bottom. Control and some other app is going to come and take all my keyboard shortcuts. I hate keyboard shortcuts. I want to use them for my live stream, and then you can't really like do that. So show. Now I need to show it, or I guess. In here, I gotta do some more diagnostic stupid stuff. No! That's not it. All right, that's that. I'm almost back. All right, I'm ready to go. Yay. Now I have... oh no. There we go. Yeah, I don't know. Sorry. Killing whatever live stream viewers I had. Unfortunately. Alright, so perceptron count. Where am I getting this? Hold on. Wait. That's why I like the total and count. So count is like if I have a stack, count of the things on the stack. Total is the total things that can be in the thing. So size is generally considered bytes. So then I just avoid size because it's ambiguous. So I just say byte, or the number of bits is the bits. It really does help. I highly recommend you taking that a little bit from it. I've been going almost 6 hours. That's good for me. Shit. N e to the x. What is n e to the x? Okay. Maybe I could go back to next probability. Huh. I feel like there might be some sort of interesting things with making the output of the LoRA match like two of the matrices. So if I could get the last two matrices, sorry, wait, didn't I have the never got the document. Do a little bit more debugging. Here we go. Gotcha. All right, so we have a square LoRA matrix. Let's just say it's like 1, 2, 3, 4 by 4. All right, so now we're gonna chop it in half. Right? Then we're gonna do this. Huh. Interesting. So how does that work? So I can't really do that. What I wanted to see. Okay. So what is the problem? This is not symmetric? I just assumed you folded it up and it was just symmetrical. Not even like doing something retarded. So what, is there always more in one of them than the other? Is that true? I'm just so confused. This thing would be. So then, you know, in order to actually have it symmetrical, it has to be like this, right? What did I just do? Oh shit. Oh man, I just messed up. Okay. So in order for this thing to be symmetrical, I'm gonna have to, like, what, have a no man's land? What am I gonna do with that? I mean, I have no problem with repurposing these. I mean, I'm actually, it's like, I just didn't. For some reason, I thought it would be like symmetrical, and you split it in half. So what happens when you do the? Love it when it's like doesn't really quite work out exactly the way you thought. All right. I thought I'd be. I guess it would be. Oops. I need to put more effort into it. Huh. All right. Okay. So. Does that look like garbage? Not horrible. Not the best. Okay, so what do we get? We do an X. Right. So what are these? I feel like there's going to be some magic pop out here. If I do something. Like, what do we know about these diagonal, right? What does it mean when there's an X? I mean, we could do like a, I mean, when there's a 1 in there going across diagonally, you know, that's an identity matrix, right? So what does that mean? Because the other plan, I mean, my plan was to split up, you know, like this is one output, and then this is B. And then this is our random number. Right. Right. So there's a random number here. When you do the neural network calculation, and we end up with these two. Maybe I should have put a star there instead. So what would result in a matrix like this? It's been so long since I've done linear algebra that I'm drawing a blank. But I feel like there's supposed to be something that's like, what does it mean when like there's a matrix that's like a. Let's ask the LLM. Sorry, I just got sidetracked thinking about it. Like, ask the LLM. How do you open that up? Isn't it like... Okay, what the hell is this shit? Okay, so maybe what I need to do is I can do so we notice there's 1, 2, 3, 4, 5 diagonal. Okay, so that's one of these lines, right? So what I can do with this is I can share this. What do I do? I'll just draw another one. All right, let's say this is 1, 2, 3, 4, 5. Okay. And then we'll call this, then we'll say this one gets 1, 2, 3, 4, 5. What did I just do? So these values can turn into an extra row for these. And then we can just make this a shared layer between here and here. So what happens when we split that up then? We end up with 1, 2, 3, 4, 5. Right? I meant to have these. Oops. It's pretty scratched. Right, so we just do a fully connected layer because this, instead of doing a fully connected layer where we have, you know, like a square matrix and where all the ones in one layer are connected to all the ones in the second layer, what we're doing is that we're dropping off, because we're, I have no idea if anybody else has done this. I'm just kind of doing it because it made sense for me at the time. So I'm doing it where each of these layers of the LoRA go up in go down one dimension. So we go start out 5 dimensions, now we're at 4. 3, 2. And then right here is where we should see these two neuron values should be multiplying 2 right here, and then where is it? Right here. So these things essentially like would transfer each of these neural network layers is an abstract mathematical function. It is just a bias times a weight, and then, oh yeah, I'm missing a bias here, huh? Oh, there's a bias, right? So that's something that I'm not calculating up in here, right? Where's the bias? I feel like I could do a K-map on this or something. What I want is you know, this should be random here. This should be random too. Right, so this one's a scalar. Right. So this one could be our scalar, or because one neuron out here is just not, this is like a scalar. Two neurons is like a more of a function. You could do more, like you could do a lot more with like 2, because 2 could be like a polynomial function where, or like a, with a squared, you know, like x squared plus b or something like that. So, but we're inputting in random values -1 to 1 because we want to do this polar rejection method. And the polar rejection method, we're working with a point on a unit circle. Okay. Right. So what the next thing I need to pull out is a square root formula, but I do need to work on the state machine. So the state machine is not, there's no state chain. All right. So this next probability needs to exist in a state machine. All right. We need index. This is the index and the sample. Sample. I don't know necessarily if I want to call this samples anymore. I mean, I could call it probability. abilities. So there's really no such thing as a negative probability, though. I mean, there can be a negative probability if you're like doing some tricks to encode an extra random bit. Like the math works out the same. All I'm doing, it doesn't matter if I'm like adding up 12 random numbers from 1 to -1. The idea is that when we add 12 random numbers where the exponent is 51, which means that we have a random number between 0 and 1, not including 1. What do I do if it's 0? Dirty probability is 0. I didn't really think about that. So this is one trick that we can do. I don't think we could. The determinant diagonal entry. What? The determinant is simply the product of the diagonal entries. Oh, because if it's a right. Sorry. If it's in this shape. Diagonal. I think I don't think a diagonal matrix is what I'm trying to say. This is where we could do some fun stuff. I know how to do this. I feel like this is what we want to do. PDP convert. A complex transformation A active simple scaling. I can do this. Variant, I can do that. No, this isn't the word that I'm looking for. Looking for what can I do with a triangular matrix? I mean, this is basically why I'm doing what we're doing, because this is like the most efficient way to convert. Like a linear combination. Would that make it hackable, though? I mean, I would like to know. That would be very impressive if you could hack something like that. I don't think you could though, because I got that pseudo random number stuff going on. Also, it's going to change. See, this is what makes it this back substitution is where I'm essentially what we're trying to break it down into. But I want to go. I feel like we could do something like this or something, dude. What a QR decomposition. What are we looking orthogonality, dude? Because we're searching for orthogonality. That's essentially what we're doing. What we're doing is we're taking the determinant. So what is the determinant? I have probabilities here. So you got to think I got probabilities, right? Okay, so think I have square matrices. They have a bunch of values that are between 0 and 1, right? They're never going to deviate beyond that. So I want to know if a number is orthogonal to another number. That's going to tell me whether or not it's random. Because if they're orthogonal to each other, like what's the probability chance that it's orthogonal, right? Very low probability chance. We could generally just disregard any orthogonal numbers. Or maybe we might have some small chance that we put it in, but that's computationally expensive. And that would make us a quasi-random number generator then, I guess, right? Let's look at this. This looks like a... What I'm looking for is a dimensional reduction trick that I don't know. I have no clue whether or not. I've done this before. I don't know how it would benefit. See, what I'm looking for is I'm looking for a way to dimensionally reduce even more than the LoRA. But this might be just a waste of my time. I mean, now we'd need a matrix solver to do this. To be honest, this looks like it'd be a good research, but I'm gonna have to hard pass on this rabbit hole. Yeah, I don't think I want to deal with this rabbit hole. I'm just gonna bookmark it in with the workspace files. I don't know what this is mathematics. Decomposition. Hermitian. I haven't heard that word in a while. Let's look at the Hermitian. What's a Hermitian? What is that one again? A transpose transpose. Conjugate transpose. Hey, Sugar, you better not be chewing the wall. Go. 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 Bunny baby. You need to be a good girl. Mm-hmm. Bunny baby. She's such a good girl. Okay. She didn't land too well. Their own fault though. A is Hermitian. F. This, okay, so is it equal to its own conjugate transpose? A square matrix that is equal to its own conjugate transpose. So how would I'm looking for dimensionality reduction tricks in here. Okay. So what am I doing with I always forget eigenvalues are. I remember how to calculate them. What do these things do? This direction is unchanged. Oh, right, like with my determinant tree. Right, so that's what we're looking for with the determinant. Right. This one. So what are we doing with this? How can I do this like the determinant? What can I do with the determinant here? I'm determining whether or not it is orthogonal, right? Because if it, let's think about this like I got a matrix, I'm taking my determinant. Okay. Right. This thing. All right, so these things are all probabilities. So let's look at this right here, or this, right? So these things, A, B, and C, these are going to be dirty. These are going to be clean input. Go from a dirty number to a clean number using my XOR for my gradient descent. Okay. So these ones are outputs, right? So we're going to be A times E times I, B, C, minus C, times, you look at the beginning in here, we've got a C, an I, a B, and A. So it's A, B, C, plus A, plus B, plus C, minus C, minus B, minus A. Okay. So, what does that mean for us? That's actually perfect if you ask me, because what is D times H? Right? That's this chunk minus this chunk. Right? So these are my number outputs. This is going to be 3 number outputs that I'm generating. Right? So now I'm taking here an input sample, input sample, and then output sample for the recurrent neural network. And then when I look at this, I'm looking at what is the probability. Imagine these things are probabilities. Every single last one of them in here is a probability. All right. So I have a probability. This is this times this. So let's say this was 1, and this was 1, and this was 0, and this was 0, right? That would mean that this would be a 1, and then DH would be a 0, okay? Times 1, and then times 0. So this C would drop out, right? And that's because these were poisoned or freak samples. So now let's go over here and look at this determinant, right? So it's a kind of a, I mean, let's take all the probabilities at 0.5, okay? So let's say I had put 0.5 here, 0.5 here, 0.5 here, okay? Or let's just make it easy. Let's drop it out. Now we got a 1, a 1, a 1, right? So what does that do? It drops the A, B, C off, and then we're just left with a function of the output. Okay? Is that a problem? What does that mean? So what that means is that my matrix gets poisoned when, and the only time that it would get poisoned is when they're all 1. First off, we can't have them all be 1s because we're generating a number 0 up to 1, not including 1. So does that make sense? I mean, it makes sense from the standpoint of, like, let's say I'm trying to protect from poisoning. What is, because these things, they could be any numbers. Let's say that they're like not a normal distribution. Let's say they're like close to each other, right? So one of them's 0.5, one of them is 0.5000001. All right. So what is that going to mean? That means that first off, the output we're going to say is random uniform distribution. So these ones are all just absolutely random number. Could be absolutely anything. And you're trying to poison the well by putting in samples that you know are going to generate highly problematic outputs. So the only really highly problematic outputs are going to be 0, 1, because the rest of them are going to be, these things are going to be some function of the neural network. Okay. And even if you did submit me poisoned samples, I'm XORing them with a running XOR. So there's just no way. It's like, I don't think that there's any possible way that you can poison it. But what does it mean, though? Right? So what are these areas? You got to think about these things as probability of A given B, probability of D given B, and so on. So now I am taking, with my determinant, I'm going to take D times H minus, A times D minus B times C. right? So let us say that we have 2 inputs and now we have 2 outputs. All right. So these are an input probability, and then this is an output probability. So what we are saying is, when we multiply these two, that this is the probability of D given A, right here. And this is the probability of B given C, okay? Right. It's not the other way around because we're trying to figure out what's the probability of the output with the last recurrent neural network input, right? And they're all initialized as random values, 0 to 1. So we're saying that what would be the result if we added the probabilities together? We would say that that is like you got a Venn diagram and you got 2 disconnected Venn diagrams. You just added those 2 up. That's what you're going to do, right? And then what happens when you subtract, right? That means that you have an enclosed Venn diagram, not a disconnected diagram. So we have concentric circles in our Venn diagram. So what we are saying is the probability of D minus A minus the probability of C minus B. So what we're going to say, B times C then we subtract them, and then the result that we're getting is, let's say it's 0. What does that mean? There's just no probability chance that that could ever happen, right? Like you're down, way down there. It's like you're in lottery winning territory. You're not getting that number, right? I mean, you could randomly, right? So you're basically showing, how big is one compared to the other. So like let's say that AD is equal to BC, right? That means that those are equal, right? So if if they were all 0.5, it would be like 0.5 times 0.5 minus 0.5 times 0.5, right? So that would be an illegal matrix right there because they're all just the same numbers, right? So that wouldn't be random in any way, shape, or form. So this is why a determinant would be helpful here. Because you got, if you start looking at it like each one of these things is a probability, I mean, this whole determinant thing takes on a whole new meaning, right? Right? I mean, usually we don't really do it with probabilities because the practice examples we use integers just because it's easy. All right, so I'm done looking at this. I want progress. Any or sign and mantissa. what else can we do? Determine an eigenvalue. Pivot. Normalize around. Okay. So here's this could be cool. This is okay. So what do we want to keep the diagonals can't be near 0, right? Dude, I'm excited about this. This sounds cool. I want to go grab an energy drink and then grab a snack because I didn't eat anything, so I'm just gonna go grab a candy bar and grab an energy drink out the fridge. I'll be right back. Wait, let me. I cannot forget what it was that I just. Oops. So what is it? Pivots and solvers. When solving systems of equations, diagonal elements act as pivots. Divide by the diagonal elements to normalize the row. You swap the row. All right. I might have discovered something here. Divide by the diagonal element to normalize a row. Zero, very close to zero. So what I want to do now is I want to convert, you know, after I've like normalized my row, I want to convert from that matrix back to a LoRA. That's what I want to do. One way to go about doing it. What is it? What did this thing just say? Convolution. What is it? What would that be? I'm already doing the convolution. That's a result of the convolution. So what is this going to do? Use convolution. This AI stuff isn't that useful. Kind of annoying. 100. All right, well, I have to go grab something to eat because I didn't eat any orange. I'm just going to go. Maybe I'll just stop the stream. I'll just come back. I can do some work off stream. I don't need to. I'm not an attention whore. I'm going to get off here.